Hi, so over the past 2 years, I've been running a math tuition center called A1 Math Academy where I tutor secondary school students math. And in this video, I want to give you a free full crash course on differentiation. Now, this differentiation crash course was taken from one of my online lessons that I conducted for my students at my math tuition center, and I'm giving it to you for free. So you'll get a full lesson on differentiation for A math, and I'll be going through the basics of differentiation, application of differentiation, and then differentiation of trigonometric, logarithmic, and exponential functions. Basically, the entire differentiation chapter will be inside this video. As you can see on the screen over here, these are the things that I'll be going through in specific with their specific timestamps. So if you want to check out a specific section, all you got to do is to go and click on the description underneath this video and just click on the timestamp over there. And also, if you want my handwritten notes that I created from scratch throughout this entire course, click the link in the description below to get access to that notes. And without further ado, do subscribe if you're new here, and let's start the crash course immediately.
Okay, welcome back. So today we are going to talk about differentiation. And in today's call, we're going to go through the basics of differentiation first, and then we'll move on to applications of differentiation. So pretty much it's just differentiation this call, but we will not go into the differentiation of sine or like trigo, exponential, logarithms. That one will be the next call. But this call is more so of getting the basics for differentiation right. So to start off, these are the 4 things that you need to know when it comes to the basics of differentiation. First is, of course, the concept of differentiation itself and how does it relate to gradient. And then afterwards, you need to know the rules of differentiation. Afterwards, we'll talk a little bit more about higher derivatives, which are your d2y dx squared. And then we'll talk about increasing and decreasing functions. And that's for the basics of differentiation. So starting off, what is differentiation? Differentiation is just a technique that we use to find gradient of a curve at any given point. Essentially, when we have an equation of a curve, once we differentiate the equation of the curve, and we get the differentiated equation of the curve, as long as we sub in any value of x, or if we want to find the gradient of the curve at any given value of x, we just need to sub in the value of x, and the corresponding value that comes out will be the value, or will be the gradient of the value. So essentially, this will be like this. And that's what differentiation is. That's why when you differentiate, let's say a quadratic equation, your differentiated version will be a linear graph, right? It'll be a linear graph that goes from negative to positive, or positive to negative, depending on the shape of the quadratic curve. And likewise, it also applies to cubic equations as well, and so on and so on. So just bear that in mind. And these are so far all the differentiation rules that you need to know, right? Of course, the basic is when you differentiate any equation, you bring down the power and then you minus 1 to the power, right? It's the complete opposite of integration, where integration is you add 1 to the power and then you divide away the coefficient, right? That one is another chapter. But I just want to stress on this point. So quite a few students got confused by this because they can't tell the difference between this and this, right? Why is it that when you differentiate, let's say k fx, why is it not differentiate k and then differentiate fx? That's because k is a scalar unit, or scalar constant. That means if k is a scalar, right, that means k is like any real number. You don't have to differentiate it. It just becomes a multiple, and you only need to differentiate the fx. Whereas if it's two equations that contains variables, that contains x, then you will need to differentiate them separately, right? And this over here, let me change this. This over here, we are talking about your chain rule. So when will you use these concepts? This concept is very commonly tested when you are doing your connected rate of change, right? When you link 3 different rate of changes together, then that's where you'll use this. If not, always remember when you differentiate, let's say any linear equation, right? And then there's a power over here, or maybe it's a quadratic equation, it doesn't matter. It's always, there's this mental like checklist that I always keep in mind. So maybe this might be helpful. So you just remember, always differentiate the power first, then you differentiate the terms that are inside, and then you differentiate the trigo if there's any, right? So this one will come in very handy when you differentiate trigo. But if there's no trigo, you can just ignore the trigo part. Just remember, differentiate the power first. So power means you bring down the n, you keep what's inside, you minus 1 to the power. And then afterwards, you differentiate what's inside. So that is power, then followed by inside. And then, of course, your last two will be your more important ones, or the more commonly used ones, will be your UV and then U over V. So this one just memorize, will do. Right? Just make sure you are doing it properly. Okay, let me write this. Yep. So that's that. Now, moving on to higher derivatives. Okay, this one is a concept that some people find it a bit hard to grasp. So I'll try to explain. Okay, this one should be pretty straightforward, right? When we differentiate y, we get dy dx. Dy dx is basically the graph that shows the gradient of y, the changes of the gradient in y as we go down the x. So if I were to label this, right, this will be y, this will be x. This will be dy dx, this will be x. This will be d square y dx square, this will be x. So dy dx is the graph of dy dx shows the change in the gradient of y as we proceed down x or whatnot, as we submit different values of x. Then when it comes to d square y dx square, right? D square y dx square shows the changes in the gradient of the graph dy dx. So when we talk about d square y dx square, right, we are talking about the change in the gradient of the dy dx. So you can think of it as whenever you do d square y dx square on dy dx, right, it's like you are doing differentiation on a completely new graph. Again, but this completely new graph represents the gradient of the previous graph. So I know it can be a bit trippy, but this is okay how it looks like. So consider this, we start off with a cubic equation, right? This cubic equation looks like that. And then we differentiate this cubic equation. So we get this, right? How we get this, we bring the power down, then we minus 1 to the power, right? We bring the power down, then we minus 1 to the power. Then x is just x to the power 1. So when you differentiate x to the power 1, you get x to the power of 0. So actually, this should be just 1. Okay, let me just bring it here. This should be 1. So let me just the whole graph. Okay, something like that. Then after that, when you differentiate it again, you get 6x plus 2. So what this means, right, is that the gradient, let's say we want to find the gradient of x at 1. So this is 1. We want to find the gradient over here. What is the gradient over here? Then we will look at the dy dx value, right? We sub x equals to 1 here. And then the corresponding value of dy dx. So this corresponding value of dy dx represent the gradient of the curve at x equals to 1. And what does this mean on the d square y dx square? So if we look at d square y dx square, if we sub x equals to 1, d square y dx square is positive. If d square y dx square is positive, that means dy dx is increasing. That means when x equals to 1, right? When x equals to 1, d square y dx square is positive. And since d square y dx square is positive, we can tell that dy dx is increasing. And since d square y dx square is increasing, that means the gradient of y is increasing. Which makes sense because as you see over here, the gradient over here is increasing, right? If we draw the tangents to this curve, the gradient is increasing. So this is how you appreciate it, essentially. When you have when you differentiate y to become dy dx, and then you differentiate dy dx to give you d square y dx square, right? You get 3 different graphs. And these 3 different graphs tell you different things. Obviously, the y is the graph, like original graph. The dy dx tells you the gradient of the point on the graph. So if dy dx equals to 0, that means that point on the original graph, the gradient is 0. That means it's a stationary point, right? It's not increasing, neither is it decreasing. Then you look at d square y dx square to tell the nature of that stationary point. So if d square y dx square is positive, that means the gradient is increasing. That means at that stationary point, the gradient is going from negative to positive. That means it is a minimum point, something like that. And then if d square y dx square is negative, that means the gradient is decreasing, right? That means at dy dx equals to 0, at that point, the gradient is going from positive to negative. That's why it's a maximum point. So that's the analogy of this. Pretty much don't have to think so much, just recognize that most of the time in Amath, we will use d square y dx square to determine the nature of the stationary point, right? And how do we define the nature of the stationary point? Is using the second derivative test or first derivative test. So that's that. Okay, then now looking at this. So when we talk about increasing or decreasing function, right, we are saying whether y is increasing or not, just very objectively. The original graph, is it increasing or is the original graph decreasing? And that's where we will need to look at the gradient of the graph, right? So if the gradient of the graph is positive, that means the graph is going upwards. If the gradient of the graph is 0, that means the graph is flatline, right? It's not increasing, neither is it decreasing, it's flatlined. And if the gradient is negative, that means the graph is decreasing. So if we were to look at this sketch over here, we can see that at different points along the graph, there will be different values of dy dx, right? So from the first interval, which is this interval, the gradient of the graph is increasing. Is positive lah, it's positive. Okay, the gradient of the graph is positive. That's why fx is increasing, because dy dx is positive. If you draw a tangent, you'll know that it's increasing, but it's increasing at a decreasing rate. Okay, if you get what I mean, the gradient is increasing, but you see the gradient here, right? The gradient is positive, but the gradient is decreasing. So dy dx is positive, but d square y dx square is negative. Because even though dy dx is positive, the gradient is decreasing, even though it's positive. That's why the rate of the change, or not rate of change, but the dy dx of dy dx is negative. Okay, that is a little bit too much. Then after that, it flatlines over here, right? It becomes a straight line. That's why dy dx is 0, because it's a stationary point. Then after that, dy dx becomes negative because it decreases, right? The gradient becomes negative. Then it becomes negative all the way until this point where it becomes flat again. Then dy dx equals to 0. Then it increases again. Then it flatlines. Then it decreases. So at any given point on the curve, as long as you are given one specific coordinate on the curve, you can find the specific gradient on that point on the curve. As long as you have the dy dx equation, then you can sub in the value of x to find the corresponding gradient of the tangent at that point along the curve. So that is the entire analogy over here when it comes to differentiation. So recap, differentiation is just a way for you to figure out what is the gradient of a curve at any given point that lies on the curve. And once we understand that, then we can straight away do some questions already, because this is still considered the basics of differentiation. So looking at this, so we're going to try question 3a, 3b, 3c, 4, 8, and 10. So 3a is just differentiate your 5x minus 4 to the power of 5. So how do you differentiate this? Remember the mental note, power inside trigo. Or in other words, you can remember PIT. But in this case, there's no trigo, so we'll just skip that. So it's just power and inside. So how do you differentiate the power and the inside? First thing is the power. So we bring the power down, become 5. Then we minus 1 to the power, right? So this is the power side. Then we differentiate the inside. Inside means we differentiate what is inside here. So we differentiate 5x minus 4, we get 5. So the entire thing is just 5 times 5, 25, times 5x minus 4 to the power of 4. So that is the answer for this. Then next, differentiate this. So you have learned, a few differentiation techniques, but none of them include the square root. So this is where, in order to solve this question, your laws of indices will come in. You need to know that square root a is a to the power of half. That's the first thing you need to know. And then once you bring that, then it's exactly the same as this case already. It's exactly the same, right? It's power first, so you bring down the power, then you differentiate the power. You minus 1 to the power. Then afterwards, you differentiate the inside. This is the inside. So 2x3 plus 5, when you differentiate it, it becomes 2. You bring down the 3, x 3 minus 1. So it becomes 6x squared. Right? And then you multiply everything together, you get this. And then you can express your final answer in this. So this is again a loss of indices, where a to the power of 1 is 1 over a. So you marry this law of indices with this law of indices, you will get this negative, bracket 2x power 3 plus 5 to the power of negative half. So that's how you get it. Then next, so to differentiate this, there are two ways. You can use uv or u over v. And it's up to you. If you are more comfortable using this, then use this. If not, if you are more comfortable using this, you can use this. And how do you use the uv? To use the uv, you must first convert 1 over 3x minus 5 to the power of 3 into 3x minus 5 to the power of negative 3. Right? This is again your loss of indices. And then once you do that, you can, this is essentially uv already, right? Then you can differentiate it. So it's u differentiate v prime. And v prime is just power and inside. Power, you bring down the power. And then, so essentially is the negative 3 you bring down, right? Then you minus 1 to the power. And then you differentiate the inside. So you differentiate 3x minus 5, you get 3. Then over here is u prime v. So u prime u is 3, right? So when you differentiate u, you get 0. And then v just remains the same. So since there's 0, anything times 0 is 0. Therefore, your final equation is just this. And then you convert this back to a fraction form. So this is your answer for 3E over here. Okay, now we move on to more situation-based questions. They say find the coordinates of the point on the curve y equals to x squared minus 1 over x when the gradient of the curve is 5. So they tell us the gradient and they want us to find the coordinates for which the gradient is 5. So in order to do that, we need to first find out what is the dy dx equation. We need to find the gradient equation of the graph, the gradient function of the graph. So we do dy dx first. So again, this case, you can use uv or u over v. But personally, I like to use uv more, right? Because I just find it easier to differentiate, but it's up to you. And also, when you use uv, your fraction looks very big, right? You have your v prime u minus u prime v over your v squared. Then you will have to deal with like a very big fraction. Whereas the first method is just all a straight line. So this is u v. So when you differentiate, it becomes u v prime, and then u prime v. All right. So that's how you do it. And then v, just note, even though it's just x to the power negative 1, the concept still remains the same. It's power then inside. So the power first becomes negative 1 minus 1 to the power, and you differentiate the inside. So regardless, it's still the same. Then afterwards, what you do is you combine these two into one fraction, and then, oops. You combine this and this into one. All right. And essentially, you just combine everything together, and then you get this. So this is your dy dx equation. So if this is your dy dx equation, that means when you have gradient 5, right, that means dy dx is 5. That means this equals to 5. Your dy dx equation equals to 5. And that's where you can solve for the value of x, right? So when you solve for the values of x, x equals to half, and then x equals to negative half. How you do that? You cross. So is x squared equals to 1 over 4, right? And then make sure when you square root anything, you need to have the plus minus sign. That means at x equals to half and x equals to negative half, the gradient of the graph is 5 at both points. So that's how you make sense of this. So the question asks for coordinates at which the gradient is 5, right? So you just sub this back into the original equation, y equals to x squared minus 1 over x. You just sub it back inside. Then you find the corresponding value of y. So therefore, your gradient equation is as such. Your gradient equation is this, your coordinates are this and this. Simple as that. So this is how you use dy dx in one specific case. Okay, now we move on to question 8. Now question 8 is more realistic type of question that you usually get. So a curve has the equation y equals to 10 minus 2 minus x to the power 4. Then they say you have a point that lies on the curve where the dy dx is 0. So if dy dx is 0, what can you tell about AB? Or what can you tell about this point of coordinate? This point is a stationary point because the gradient of this point is 0. And that means that it is neither increasing nor decreasing. That means it's stationary. So to answer this question, we need to first figure out, what's the value of A and B, right? We need to first find out what are the coordinates where the dy dx is 0. So the first thing we do is to differentiate your curve equation. So in this case, 10 minus this. So when you differentiate this, you become d dx 10 minus d dx 2 minus x to the power 4. This is 0. This is this. So the negative is originally there because of this negative sign over here. So you're just differentiating this. 4 you bring forward, you minus 1 to the power, and then you differentiate the inside. 2 minus x, when you differentiate it, it just becomes negative 1. So when you re-expand it, the negative sign cancels out the negative sign. Then you get 4 times 2 minus x cubed. And since dy dx equals to 0, that means this whole thing equals to 0. The 4, you can take it out, and then you can also take out the cube. So 2 minus x is 0, therefore x is 2. And then from here, you can find the coordinates of a and b. So now, the question asks, is y increasing? So essentially, is dy dx positive? So just to put here, if y is increasing, means dy dx is positive. If y is decreasing, that means dy dx is negative. So if y is increasing, dy dx is positive. If y is decreasing, dy dx is negative. So how can we tell if y is increasing or not when x is lesser than 2? Right? So that is where we need to figure out, okay, what is my dy dx equation? My dy dx equation is 4 bracket 2 minus x cubed. So if x is negative, that means, looking at this, if x, let's say, is okay, if x is less than 2, right? So let's say x is 1. That means 2 minus 1 is 1, which is positive. And let's say x is, let's say, negative 3. 2 minus negative 3 gives you 5. So regardless of any value of x, if it's below 2, it means that 2 minus x will be positive. And when you have a positive number and you cube it, it will still remain positive. And when you put a 4x multiple on it, it will still be positive. And therefore, when x is less than 2, you can say with confidence that your dy dx is positive. And since your dy dx is positive, you know that your y is increasing when x is less than 2. And on the other hand, when x is more than 2, 2 minus x, right? This originally your dy dx equation is this. When x is positive, or when x is more than 2, so let's say x is 3. 2 minus 3 is negative 1, which is negative. Right? 2 minus 10 is negative 8, which is negative. So you know that 2 minus x will remain negative as long as x is bigger than 2. When you cube that number, it will still be negative. Right? When you have a negative number, you cube it, it will still be negative. And when you put a 4x multiple on a negative number, it will still remain negative. Therefore, dy dx is negative. And that's how you know that y is decreasing when x is bigger than 2, simply because dy dx remains negative for x is bigger than 2. That's how you answer this question, is to use your dy dx equation, and then you think to yourself, okay, essentially you work forward, right? If 2 minus x is positive, that means 2 minus x cubed is positive, that means 4 times 2 minus x cubed is positive, that means dy dx is positive. That's how you essentially work this question. Okay, question 10. So now we have engine, okay? We have an engine, and then the temperature is modeled after this equation over here. So they want you to determine whether temperature is increasing or decreasing. So how can we tell whether our original temperature, whether is it increasing or whether it's decreasing? We need to look at the dy dx or the dt dx in this case. So first thing to do is to differentiate this. And that means you are going to differentiate this, and this separately. So when you differentiate this, okay, before you differentiate this, the first thing I did was to change this to the power 1/3. And then likewise for this, I changed this to the power form also 100 times x plus 2 to the power negative 1. And then 75 is just 75. Right? Because I prefer to use the chain rule over the u over v. But it's really up to you. So when you differentiate this, it then becomes very clear, right? You bring down the power, then you minus 1 to the power. So you end up with this. And on the other side, the 100 is a scalar multiple, so you keep the 100. Then you bring down the negative 1, right? And then you minus 1 to the power, so it becomes negative 2. And then the 75, when you differentiate it, it becomes 0. So that's how you do it. And then from here, what you can do afterwards is to re-expand them again. So you know that it's 1/3 times 1 over x to the power 2/3, which is just 1/3 times 1 over cube root x squared. Right? This is your loss of indices. AMN equals to NAM. That's your loss of indices. MN. Right? So that's your loss of indices. So that being said, okay, let me erase all this. Now that you found out your dt dx equation, and then they say they want to determine whether this is an increasing function or not, but you need to take into account the context of the question. So in order to determine whether dt dx is increasing or not, you need to figure out what's your x, right? Because your dt dx comprises of your x. X is the only variable. And in the context of this question, x refers to time after it has been switched on. That means you need to own self deduce that x is positive, because firstly is x refers to time, right? And in the context of Amath, time is positive. And number two is that we are talking about the time after it has been switched on. So x is definitely positive. So since x is positive, that means we look at our differentiation equation over here. If x is positive, that means when even if you square it and then you cube root it, and in this case, even if you plus 2 and then you square it, it will still remain positive, right? And even if you multiply 3 to it, it will still be positive. So what we're trying to do here is we're trying to work backwards to prove that regardless of any values of x, the dy dx value will always be positive. dt dx will always be positive. And how to prove that dt dx is always positive for any value of x? We need to prove that the individual components of dt dx is positive for any values of x. That's why we start from the most basic, the smallest part of the dt dx, and then we work upwards to form the entire dt dx. So since dt dx is positive, that means we know that the gradient of t is increasing. Or it's positive, it's not increasing, but it's positive. We know that since the gradient of t is positive, it is a increasing function because it is, the gradient is going upwards. That's why t is increasing. And that's the analogy behind this. Okay, so this is the sort of the basics for differentiation. When we go through the tutorial questions, we'll go through all of the TYS questions together when it comes to differentiation. Okay, and we have covered the basics. We will move on to applications of differentiation. So looking at the notes over here, applications of differentiation. Okay, so now whatever you have known when it comes to differentiation, we are going to use it to answer situation-based questions. Okay, let me bring this here. And what situation-based questions must you learn how to answer apart from your usual real life questions? These three type of situations are your bread and butter for differentiation. Essentially, they are your finding your equation of your normal and tangent, rate of change, which is your chain rule, and determining the nature of stationary points. So let me just add a note here. And of course, you have your real life application. So these are the sort of the bread and butter for this entire chapter. Yep. And sorry, Akila, could you help me mute yourself first so that you won't be in the recording? Okay, thanks. Okay, so carry on. So first thing is talking about your equation of normal and tangent. So in differentiation, we know that when we differentiate an equation, we are finding the gradient function of the equation. And essentially, we are able to find the gradient of the point on any curve. And the gradient of that point is referring to the tangent, the gradient of the tangent at that point, right? If you look at this. So once we find out what is the gradient, right, of any tangent, essentially you need to remember two formulas, and you will use these two formulas again and again and again when it comes to this chapter of trying to find the normal and the tangent, which is y minus y1 equals to mx minus x1, as well as your gradient of the tangent multiplied by the gradient of your normal is -1. That will always be the case. So you're looking at this. Once you determine your gradient, right, which is determined using your dy dx plus sub in value of x at the point of which you want to find gradient. Then all you got to do is to just sub in that same pair of coordinates into here. So essentially, you just sub in this, and then you will be able to find your equation of your tangent. And then to find the equation of the normal, you just need to first find your equation of your gradient of your tangent, and then you just take -1 divided by your gradient of your tangent. And immediately you will be able to find your gradient of the normal. Why? Because these two lines are perpendicular to each other. Your normal is perpendicular to your tangent. And at the same time, your normal also passes through this point, right? Chances are the question will ask you to find the normal to the curve at this same exact point as well. But no worries, if the question asks you to, find maybe the normal at this point, it's also the same concept, because the normal is always perpendicular to the straight line tangent, and the gradient will always be the same. You just need to make sure you sub in the correct, pair of coordinates. So whatever I said is exactly what I've written over here. This is the summarized version, right? The step of whatever I said. So step 1 to 5 is here. This is how to find equation of the tangent. And then for equation of normal, there is just one more extra step. Is to just take -1 divided by the gradient to find the gradient of the normal. So you can slowly read this. It's exactly what I said earlier. You just need to get your gradient, then you sub it into y minus y1 equals to mx minus x1. And then you will have your answer. But always make sure to express your answer in terms of y equals to mx plus c when you are finding the equation of a straight line. All right. Okay, so that is the first bread and butter of this entire equation, this entire chapter. The next one we are going to talk about is rate of change. So rate of change is an interesting one because it requires you to read the question very clearly, because sometimes the question will give you certain values that you need to plug inside your rate of change. And this rate of change, usually, in what context will we use this? We will use this in context like volume, is to volume, radius, maybe area, length, so on and so forth, is when you have an equation, let's say a volume equation that connects to radius, and then both the volume and radius are changing over time at the same time. So it's like, let's say V equals to 1/3, or let's say area is pi r squared, right? Circle, equation of a circle. Area itself is a variable. Radius itself is a variable. But these two variables can also change with respect to time. So example for this would be, let's say you have a puddle of water, right? The puddle of water, assuming it remains as a perfect circle. The area of this puddle of water is A equals to pi r squared, right? No doubt about that. But let's assume that it's raining. So as it's raining, the puddle will get bigger and bigger. And that means that your area will change and your radius will change over time, right? Area will increase and your radius will increase. So we can say that dA dt, this is talking about the change of your area with respect to time is positive, it will increase. And at the same time, your dr dt is also positive, because your radius will increase as more water goes into the puddle. So from here, we can get three different kinds of differentiation already, right? dA dt, dr dt, and in itself, this we also can get dA dr, right? We also can measure the change of A with respect to the change in the radius. So this connected rate of change is to help us to link these three together, is to link these three seemingly separate events together. So yeah, that is how we do that. So this is basically the equation. And I know this is not the right way to do this, but how you can remember this, right, is that as long as this one strikes out this one, so it's you are only left with dy in the top and then dx at the bottom. That's how you know you have gotten it right. It doesn't work like this. Okay, I say first, it doesn't work like this at all. Okay, they don't cancel each other out. But this is visually a way for you to sort of remember and make sure that your rate of change, your connected rate of change equation is correct. Okay, so that is just a mental note. So in the previous context, where we talk about the puddle of water, how can we link these three together? Right, so dA dt equals to dA dr times dr dt. That means the rate of change of the area equals to the change in the area with respect to r multiplied by the rate of change of radius with respect to time. And how do we know that we have constructed this correctly? That is because this one cancels out this one, and whatever we are left here is the same as whatever is left here. So it's exactly the same. So that's how we know we have constructed this right. So that is the rate of change. And just another example over here. So consider this hemisphere bowl, right? The equation of a sphere, the volume of a sphere is 4/3 pi r cubed. So in this context, since it's a hemisphere, that means it's half of a sphere, we divide by 2. That's why it's 2/3 pi r cubed, right? And from this itself, from your V equals to 2/3 pi r cubed, we can immediately essentially get one differentiated equation, right? We can find the change in V with respect to the change in R. Okay, so that's that. Now the context of the question is, as water is transferred into the bowl over time, so as they pour more water into this, right? Two things will change. As more water enters the bowl, the volume of the water inside the bowl will increase, definitely. But at the same time, the radius of the water inside the bowl will change, right? Because it's a hemisphere. Let's say the puddle of water is here. The radius from here to here is different from, let's say, the radius from here to here. So the radius will also change over time. That's why we will also have two separate equations where we can also measure the rate of change of the volume with respect to time and the rate of change of radius with respect to time as well. And how do we connect these three together is by using the mental note that I went through just now, right? As long as this cancels out this and this together gives you this, then you know that you have constructed your sort of rate of change equation correctly. Okay, and later I'll go through how we are going to apply this to answer questions, but most likely the question might tell you, right? They say, okay, your water is being the volume of water inside the hemisphere bowl is increasing at a constant rate of 5 cm cubed per second. That means we know that this 5 cm cubed, right? Immediately we just give it that value. And then they might want us to find what is the RDT. They want us to find what is the RDT, and they will tell us that they want us to find the dRdt when R is, let's say, 5 cm. So we will need to sub in R equals to 5 cm inside this inside dV dr to find a value of dV dr, and then to find dr dt, we just take dV dt divided by dV dr. I know it's a bit hard to grasp without any context, so we'll go through in the question later. But that's rate of change for you. Rate of change is essentially can be summarized by this sentence. If two variables, x and y, both vary with another variable t, like the volume and the radius, even though they are connected to each other, they also can vary with time, right? So the rate of change with respect to time can be related by this chain rule equation. Okay, and the last one, the last point of this entire chapter is the concept of stationary point and the nature. So I'm just going to write it here. So what does it mean by stationary point? Stationary point means at that point along the curve, the gradient is neither increasing nor is it decreasing. Therefore, you know, your dy dx equals to 0, right? And then now we essentially ask ourselves, so if dy dx is 0 and the gradient is not increasing or decreasing, that means the gradient can be one or three things. It can be a minimum point, it can be a maximum point, or it can be a point of inflection. What does it look like? So for maximum point, it looks like that, right? Where the gradient is flat. For minimum point, it looks like that, where the gradient is flat. For point of inflection, let's say this is the dy dx is 0, is flat. Likewise, for this case, it's flat as well. Right? I know the drawing is not really good, but hopefully you get my point. Is that even though it's a stationary point, it's too vague for us to say what type of stationary point it is. We need to, if we want to get a level deeper and figure out what type of stationary point it is, we need to perform one of the two tests. First derivative and second derivative. So first derivative is called first derivative test because you do not differentiate the dy dx again. You do not get d squared y dx squared. All you do is you draw a table like this, right? And you know that, let's say, when x is 1, dy dx is 0. So your only job, or is essentially your only mission here, is to figure out what is the gradient before this point and what is the gradient after this point. And you don't want to find the gradient like way before, right? If it's too far away, it might not be accurate. And if it's too near, it also might not be. I say if it's too far, yeah, it's not accurate. So that's why we just minus 0.1 And that's why we just plus 0.1. So these values over here, so this one will become 0.9 and this one will become 1.1. Then all you got to do is to sub this and key into your calculator. So you sub x equals to 0.9 into the dy dx equation, and then you key into your calculator. And then if it comes out as positive or negative, then you key over here. Likewise for this. So once you figure out what is the gradient at x equals to 0.9 and x equals to 1.1, then you can sketch the tangent, right? If the gradient is positive, that means the tangent is pointing upwards. If it's negative, then the tangent is pointing downwards. Then once you figure out the shape of the tangent for these 3 points, then you can sketch an outline on the graph. And in this case, this will be a maximum point, right? Maximum point. But on the other hand, if you don't want to draw the table, you also can do a second derivative test. This second derivative test essentially is what I mentioned earlier, is to differentiate the dy dx again. So you d dx, dy dx. So now you're treating your dy dx equation as a completely new graph. And you're differentiating this completely new graph, which is also the graph that determines, or it's also the graph that represents the gradient of the initial graph. Okay, so I know it's quite confusing, but just slowly think about it and then you will catch it. So it means, right, if d square y dx square is positive, that means, okay, so how do you get this, right? Is that first you differentiate your dy dx equation. So you get a new d square y dx square equation. Then they want to find the nature of the stationary point, let's say at x equals to 1. So initially, when you sub x equals to 1 into your dy dx, your dy dx equals to 0, right? So that means that at x equals to 1, the point on the curve is the stationary point. But now we're trying to determine the nature of this stationary point. So you get your d square y dx square equation, you sub in x equals to 1 inside this d square y dx square. And that will give you a value, right? And if this value is positive, this shows that your dy dx is increasing, right? And since your dy dx is increasing, at your stationary point, your gradient is going from negative. You can think of it as going from negative to positive. And therefore, you can conclude that at that point is a minimum point, right? Because your gradient is going from negative to positive. And if your d square y dx square is negative, that means you can tell that your dy dx is decreasing. And since it's decreasing, your stationary point is a maximum point because your gradient is decreasing. But what if you do your d square y dx square again and you get equals to 0? Then that's not really constructive, isn't it? Because once we get d square y dx square equals to 0, it still doesn't tell us anything about the nature of this stationary point. We still cannot tell whether it's a minimum, it's a maximum, or it's a point of inflection. And that's where you will need to you will need to head back to your first derivative test and perform this test again. So essentially, if you get d square y dx square equals to 0, you have just wasted your time, because you could have just went straight to first derivative test because you will have already needed to, you will still need to do it either ways. So a lot of students ask me, so which test should I use? Should I use the first or the second, if not specified by the question? So to that, right, I'll recommend, I will say, look at the dy dx equation. If the dy dx equation is simple to differentiate, right, it's like maybe 3x squared plus x or something like that. If it's easy to differentiate, then use the second derivative test. But if it's really complex, it has a lot of fractions, there's a lot of power, you still need to use chain rule and all these kind of things, then just stick to the first derivative test. So in short, I would recommend the path that is easier to do, right? If differentiating is going to be harder than just drawing the table, then I would just stick to first derivative test and draw the table. But if differentiating is going to be so easy that drawing the table would take more energy and effort, then I'll just stick to the second derivative test, unless specified by the question otherwise, right? If the question wants you to die use second derivative, then you have no choice but to just use it. Okay, so yeah, that's what I mean. And whatever I just said is exactly what I sum my solution. And if you need another reference, this is how the table looks like. If you still don't have a solid way of presenting your answer using first derivative test, you can just copy this. The middle value here will always be your x coordinate where your dy dx is 0. So essentially, this one will always be constant. Like you can just memorize this together. Then you are supposed to find out what's this, and then you're supposed to find out what's this. Then eventually your final answer, you will choose either one of this. That follows the sketch of the tangent. So that's the analogy behind this. Okay, if not, these are the three main concepts for this entire chapter of applications of differentiation. Tangent, normal. Rate of change, and stationary points and their nature. So that being said, let's try some questions, because really there's only these three concepts that will be tested again and again and again. So looking at your questions over here, we're going to try 4 questions. And 8, 9, 10, 11. Okay, so now looking at this. Question 8. I've drawn it out again, so can annotate. Okay, so they're saying that you have a triangle and then you have a curve. And the curve is a quadratic curve because it's x squared. Now, B is a variable point. So take note, this is a variable point, which can move along the curve anywhere from here all the way until here, where x is 6. And they tell you that BC is parallel to the y-axis, and then A lies on the x-axis. So they want you to express the area of the triangle, TCM squared, in terms of x. So part I is actually pretty straightforward because, this is a 90-degree triangle, right? So it's just half times base times height. So it's half times base times height. But the thing is that your height here is referring to the y-axis. Here is y. That's why we get 3y. But the question wants us to express in terms of x. So we need to essentially express our y in terms of x. We need to sub some value of x inside here to replace the y. And just nice how we do that is because this point B lies on this curve y equals to 2x squared plus 3. That means it lies on the curve, right? That means it follows this equation. So since y equals to y, in this case, that means this y can be modeled after this. Therefore, it's just x comma 2x squared plus 3. So you can sub 2x squared plus 3 inside here. So it's 3 times 2x squared plus 3. Okay, I repeat. The B lies on the curve. Y equals to 2x squared plus 3. So if you want to express y in terms of x, usually you need to come up with some sort of equation to link these two together, right? But since B lies on it, that means the value of x essentially can be modeled, or the value of y can be modeled after the equation y equals to 2x squared plus 3. So that is how you essentially get that y equals to 2x squared plus 3. And over here. So this is T. Then now they want you to just differentiate this, right? So it's just very simple. This one, you differentiate this, it becomes like nothing. So you bring forward the 2, it becomes 6 times 2. So this is supposed to be 12. 12, then here is what? So it's 12x squared, right? So that being said, now you have 12, 12. So they say when x equals to 2, t is increasing at the rate of 0.8 units square per second. So find the corresponding rate of change of x at this instant. Okay, we break down this question first. So the question is saying when x is 2, dt, dx, dt. Okay, I know it's quite confusing. This t refers to the area of the triangle. Then this t refers to the time. So dt is 0.8 units square per second. Okay? And initially what we have found is that we have found dt dx. So they want us to find the corresponding dx dt. They want us to find what is this. So we need to link the equations together first. So the question gives us dt, which is 0.8. This is what we have found in I, and they want us to figure out what is this. So we sub in the values over here. Right? So dt is 0.8. This is 12x, and then we want to figure out what's this. So they want, and then they tell us when x equals to 2, that means we just sub in x equals to 2 over here. So it's just here, like, x equals to 2. So it's here supposed to be 12 times 2, which is 24. So it's just 0.8 divided by 24. And we get 0. Or rather we can express in fractions, so it's just 1 over 30 unit per second. Okay, so this is actually how you do it. Is that you need to first formulate this. And how do you know that this is correct? It's because visually, this one, cancel this one, gives you this one, which is the same as this one. So that's how you know visually you're correct. But conceptually, that's wrong. But just teaching you what works. And then you just sub in the value of x when x is 2, because that's given by the question over here. Okay, so great. That's that. And let's move on to the next question, which is question 9. Okay, so 9. We have a curve, and we have this curve over here. It has a minimum point. Now, the question wants us to show that the minimum point of M satisfies the equation x cubed equals to 4. So essentially, if we sub in the coordinate, the x coordinate of M inside this equation, you'll get 4. If we sub the x coordinate of M into x cubed, we'll get 4. That's what it means. It will satisfy the equation. So how do we find the x coordinate of M in the first place? We know that it's a minimum point. And for minimum point, it's a stationary point. And for all stationary points, dy dx equals to 0. So the first thing we do is to differentiate our equation over here. So d dx or dy dx equals to 2x plus 8 to the power times x to the power of negative half. So again, I changed this to this because I prefer to use UV. And I prefer to use UV and the chain rule over UV, U over V. But again, it's really up to you. But just advice, right? When it comes to differentiation, everything's already so messy. And if you have a very, very big fraction over there, I think it just increases the chance of careless mistake. But if you are good with it, then you just stick with it. It's up to you. Personal preference. Okay, so now we differentiate this whole thing. 2x becomes 2. Then over here, we do our 8 times this, right? 8 is a scalar, so we don't differentiate 8. And now we just differentiate x to the power of negative half. So what does it become? We differentiate the power first. So bring down the power, negative half, x, then we minus 1 to the power, so it becomes negative 3 over 2. And then we differentiate the inside, which is x, gives us 1. So ultimately, we get this 2 minus 4 times x to the power of negative 3 over 2. Which also means that we use back our laws of indices to change this back to a fraction. So you get this. So 2 minus 4 over square root x cubed. So this is our dy dx equation. Then all we got to do is to find out what value of x satisfies this, where dy dx equals to 0. So we want to find out the value of x when dy dx is 0. So we let dy dx equals to 0, and then we solve for x. So this should be pretty straightforward. You should get this. And then to prove that, it satisfies the equation, I think a proper way to, a good way to present your answer, right, is to just use the left-hand side, right-hand side concept. So you express your answer is left-hand side first. Left-hand side of the equation is x cubed. Then you sub in the value of x, which is 2 to the power of 2/3 inside. Then you get 2 to the power of 2, which gives you 4, which equals to the right-hand side of the equation, which is what we're trying to get, which is shown. So yeah, I think for this part is more so of your presentation. But if you have any other ways that you're more comfortable with, you can go ahead with that. But I personally feel like this is a very, very good way to show your answer. It's very proper. Okay, so now that that's done, now we have another part of the question. So we have point P and point Q that lies on the curve, right? And the respective coordinates are given. The tangents to the curve at P and Q meet at point R. So essentially, if this is the curve, and then this is P, this is Q. So this is P, this is Q. And then you have two tangents. So for example, this is the tangent, this is the tangent, and then they meet at R. That's what the question is trying to say. So the question wants us to determine whether the x-coordinate of R is greater than the x-coordinate of M. And we already know the x-coordinate over here of M in the earlier question is 1.5874. So how do we do this? So, or essentially, how do we find the x-coordinate of R? We need to find out where is the intersection between the two tangents at P and Q. So to do that, we need to find out what is the equation of the tangent at P and Q. So in order to find out the tangent to P and Q, we need to first find out what is the gradient of the tangent at P and Q first. So you see, right, I'm visually, not visually, I'm verbally, explaining my thought process behind this question. And this is how you work backwards to your first step as to what step you should take. So, I mean, it makes sense because we already know coordinates of P and Q. So all we got to do is to just find the tangent, find the gradient, then we can find the equation of the tangent, and then we can find the point of intersection between the two tangents. So in order to find the gradient, we need to find the dy dx first, which is essentially what we did earlier on. So to find gradient, we just sub in the x value. X is 1, so it's 1 cube. So it becomes -2. Then this is your m. So using your y minus y1 equals to mx minus x1, so this is your m, this is your x1, this is your y1. The question has given you that p is 1, then, so we just use this. And then you will get this equation for the tangent at p. Then we will repeat the process for q. Right? You sub in the x value, you get the gradient of q. Then you use y minus y1, which is 12, and the x1, which is 4, and then the gradient is 1.5. It's given here. You expand everything, you get y equals to 1.5x plus 6. So now that you have the equation of the two lines, then it becomes fairly simple to find the intersection, right? You just let the first line equals to the second line, and then you solve for the value of x, right? So x equals to 5.14285 ... which is greater than the x-coordinate of m. So therefore, our answer will be the x-coordinate of r is greater than the x-coordinate of m, because we are just simply answering the question. But this part, I test you on the application, right? Just now I mentioned the equation of tangent. And if they wanted to, they could even ask you to find the equation of normal as well. But it's not relevant now in this question. Okay, moving on. Question 10. So we have this open cylinder, right? And then the diagram is as such. This is R/3, this is H, this is R. And they want us to show that the total external surface area is given by this. Okay, so what is our total external surface area? It's basically this whole thing plus the base, right? That's it. It's this whole entire thing that I just highlighted plus the base. Now, notice that in the question, they say A equals to 5 pi r squared over 3 plus 80 over r. There is no presence of h at all. So that means what? When you look at this and then you realize that how can it be no h? Because, eventually we will still have to use h because h refers to the height. And we're trying to find the surface area of, the entire thing. We will need the height, or essentially we will need h. That is where you need to read the question a little bit more. So the question already gives you a clue when they say, when the cylinder contains 40 meter cube of liquid, the height is h. So if you recall in your mensuration chapter, right, basics of mensuration in E-Math, volume is base area times height. Your base area is a circle, right? And your height is h. So you can come up with this equation. Pi r squared h is 40. And you know that your final answer shouldn't have a h inside. But eventually you still need to use the h. So what must you do? You need to express h in terms of r. Essentially, you need to replace the position of h with r. And you know you have to do this because the final answer in the question does not contain any h. So once you do that, then it becomes very easy. Total external surface area. This one is the part that I highlighted. This part is the base. The base is a circle base, so it's just pi r squared, right? Then this is talking about the external surface area that I just highlighted. So this one is the height, right? And then this one is the circumference. Oops. Circumference. Because this entire external surface area, if we were to lay it out like that, this one is the circumference of the circle. Then this one is the h. h plus r over 3, which is this. And then we will sub our h for this that we have derived from the question. So from here onwards, it's just, multiplying and then expanding properly. So this one multiplied by this gives you this. This one multiplied by this gives you this. And then this remains as pi r squared. And then afterwards, you eliminate. And then you you can actually combine these two to give you 5 pi r squared over 3. And at the same time, you can also bring this over here. And essentially you get what the question is asking for. You get that A equals to whatever this equation is. So you know that you answered the point. Now, they say given that r can vary, so the radius can vary. Find the value of r when A is stationary and the corresponding value of h. So when A is stationary, that means dA dr equals to 0. So dA dr is 0. So we need to first find out what's your dA dr. So if your A is this, which is what we have found earlier on, we can express it like this, right? Your 1 over r is just r to the power of -1. And then likewise for the other side, not much change. So when you do your dA dr, you will get this. And when A is stationary, you get dA dr is 0. So what the question is asking you is, they want you to find the value of r when this whole thing equals to 0. That's all they're asking for. So it becomes, fairly simple, right? You just let the entire dA dr equals to 0, and then you solve for the value of r. So r cube is 240 divided by pi, and then you cube root the entire answer, give you this. Express your answer in 3SF. Now, just a note, when you square root something, you need to put the plus minus sign. But when you cube root something, you don't have to put a plus minus sign. Because when you square root a number, answer can be positive or negative. But when you cube root an answer, if you are cube rooting a negative number, the answer will only be negative. And if you cube root a positive number, the answer will only be positive. So that's why cube root, there's no plus minus. Just a side note, if you were wondering. But square root have. So the answer for this is 1.97 to 3SF. Okay, now in question 11. Question 11, we have a open box of height HCM, triangular base of the sides 13x, 13x, 10x. So looking at this, you immediately can tell this is an isosceles triangle. The volume is 3840 cm cube. So they say if the total internal surface area of the box is a cm cube, show that a equals to 2304 over x plus 60x squared. So internal surface area. So internal surface area is just what? Whatever is inside, the three sides plus the base. Right? So looking at this, to find the base first, how do you find the base? This is where you need to use Pythagoras theorem. Right? Because this is 13x, this is 13x, this is 10x. You have no idea what this angle is. You have no idea what this angle is. You have no idea what this angle is. Sure, you can use cosine rule to find the angle, right? You can definitely do that, and you will probably find the area of this. You can also find the area of the triangle as well, right? Because once you find out what's this angle, then you can use half AB sine C to find the angle of the triangle. But there's a simpler way, and that is to use Pythagoras theorem. So if you draw an imaginary dotted line now here and label this H, you will split this triangle into two, right? So this one becomes 5x and this one becomes 5x. So based off our Pythagoras theorem, a square plus b square is c square. C square is your 13x square, and then your b square is your 5x square. So h square plus 5x square equals to 13x square. So by using Pythagoras theorem, you figure out that h is 12x. So the entire surface, the entire internal surface area, right, is just the area of the base of the triangular base, which is half times base times height. So it's just half times 12x times 10x, which is what we found earlier on. And then at the same time, you will multiply by the internal surface area over here. So, which is just h times 13x plus 13x plus 10x. And how do we derive that? Is that you know that let's say here is h, right? Then here is 13x. And here is h, then here is 13x. So it's just h times 13x plus h times 13x, then the remaining is the 10x. But you can just factorize them to get this. So this part shouldn't be a problem. And then when you expand everything, you'll get this. But again, this is not our final answer because the question, if you realize the question doesn't have a h inside, right? It's just 230 divided by 4 plus 60x squared. So how can we express h in terms of x to fit this question? And that is where we read the question a little bit more, and then we realize that the volume of the box is 3840 cm cube. So if the volume of the box is 3840 cm cube, and we come up with this volume equation, we know that height times base area, which is this, equals to volume, right? Volume equals to base area times height. So this is your height, this is your base area. And this base area can only be found if you get this right. So once you do that, you can essentially express h in terms of x, right? You just, you multiply this out, everything, you get 60x squared. So 3840 divided by 60x squared gives you 64 over x squared. So that is where you will then sub back this h inside here, and you get this, and then you establish your equation as such. Then the next part, I, is fairly simple. They say find dA dx and d square a dx square. So they just want you to differentiate the types. So you just differentiate this one to get this one. So you differentiate 60x squared, you get 120x. Then this one can be expressed in terms of 2304 x to the power negative 1. So you differentiate the power negative 1, and then you differentiate this one. So it becomes this. And then you just repeat the process for this again. So 120x, when you differentiate it, you get 120 because the x is gone. And then this one is just, again, 2304 times x to the power negative 2. So you bring the power down, then minus 1 to the power, you get this. Plus the negative sign. So eventually, this is your answer. That's for II. Now, the last part, they say, hence, find the value of x for which A is stationary and determine whether this is maximum or minimum. So, standard question, very, very standard question. If A is stationary, means dA dx is 0. So you let dA dx equals to 0 using the equation that you have found in part II. You solve for x, right? You bring, since this is negative, you bring this over to the other side, you get this equals to this. You cross multiply this, you get x cubed. You bring 120 over, you get this. And then to solve x, you just cube root the entire thing. And then you get x equals to 2.68 or 2.67 dot. And then from here, you've got two options. You can use first derivative test or second derivative test. It's completely up to you. But you just look at your II, right? In II, you already found d square A dx square already. And the question even asks you to use, the question even say hence. So this is a clue to you that you should be using your d square A dx square, right? Because number one, you have already found it in II, so might as well use it. And number two, the question already say hence. So yes, this is to a sign that you should use your second derivative test. So you just sub in your value of x into your d square A dx square. That means you sub it inside here. Key to your calculator, you get a positive value. And since the value is positive, that means d square A dx square is positive. That means dy dx is increasing. And since dy dx square, dy dx is increasing, that means the gradient is going from a negative to a positive, right? So in fact, this should be right, because dy dx is increasing. That means the gradient is going from negative to positive. Since d square A dx square is positive, so therefore this value of A is a minimum because the gradient is increasing. So yeah, that's it for this lecture. Just a quick recap. Up until this point, we have finished normal differentiation, and then we have even finished application of differentiation. So now what's, all that's left to do is to go through trigonometry, exponential, and logs when it comes to differentiation. But the concepts are still the same, right? The differentiation rules are all still the same. So for the notes for this part of the chapter, there's really nothing much for me to go through, except just breaking down the chain rule. So just a quick reminder, for trigonometric functions, when you differentiate them, you have to make sure that you always follow this sequence. Okay, you may not follow exactly this sequence, but when you differentiate it, you must ensure that the steps are there. So it's always three things to differentiate. The power, followed by the term that is inside the trigo, and then the trigo term itself. So as you can see over here, when let's say we have to differentiate tangent 3x, the whole thing, okay, let's say we have to differentiate tangent cube 3x. How do we differentiate this? The first thing to differentiate is the power, so which is the 3. That's why we bring the 3 down, tangent square 3x. This is the first thing to differentiate. We are literally only differentiating the power, followed by the inside. So what's the inside term? The inside term is 3x. So when we differentiate 3x, what do we get? We get 3. And then the last thing to differentiate would be the trigo term itself, so tangent 3x. When you differentiate tangent, you get secant squared. So you get secant square 3x. So this is your entire differentiated version of tangent cube 3x, right? So again, power inside trigo. How can you remember this? You can just remember this as like PIT, like PIT, power inside trigo. Yeah, that's really much it. Then for exponential functions and logarithm functions, it is what it is, right? If you differentiate ex, you get ex. You differentiate e to the power of fx, you get f prime x e to the power of fx. So the only difference is the x and the fx, right? If it's literally just x, then you will just remain as x. But if it's f prime x, or if it's fx, that means it can be like e to the power of 2x plus 1, or even like, let's say, e to the power of 3x, or even e to the power of like 10x. As long as it's not x, then you will follow this, where you will differentiate the power first, and then you will differentiate, and then you just copy over the e to the power of fx. Then for logarithm functions, when you differentiate, it has to be ln x, right? And then when you differentiate ln x, you get 1 over x. And then when you differentiate ln fx, you get f prime x over fx. This is not included in your mathematical formula, so need to remember. And that's it. That's really it for this entire chapter. It's more of the application. But then I decided that for today's session, I will go through half. So I did half of the questions, because the other half of the questions I wanted to do live with you, so that you can see like how I think through when I do the questions. So that being said, this is the questions for today. So we are going to go through differentiation, and questions are over here. Okay, so a lot of questions are up until question 65, but I did all the way until, I believe was, let me see, I did all the way until 44. So after question 44, we will just do it live. So as you know, our differentiation is a very, very, very big chapter. And as in calculus in general, is very, very huge. So this will be probably like at least 20% of your entire paper. All right, let's do it. So question 4, the point P lies on the curve y equals to x times ln x. The tangent to the curve at P is parallel to the line y equals to 2x minus 3. So we know that if two lines are parallel to each other, the gradient of the two lines are the same. They have the same gradient. So means the tangent to the curve at P has the gradient of 2. So how do we find the coordinates of P in that case? What we can do is that we differentiate y, so we get dy dx, and then since dy dx represents the gradient of the curve y equals to x times ln x, if we let dy dx equals to 2, we essentially can solve for the value of x on the curve y equals to x ln x. That will give us a gradient of 2. And then that value of x will be our x coordinate of point P. So the first step is to differentiate x ln x. And this is just your product rule, uv. So when you differentiate uv, you get u v prime plus u prime v. U v prime plus, okay, let me just put v u prime. So ln x is just, when you differentiate ln x, you get 1 over x. And then when you differentiate x, you get 1. So therefore, it's just like that, right? U means the x remain, and then ln x becomes 1 over x. Then on the other side, you differentiate the x, you get 1. So in the end, your new differentiator equation is just 1 plus ln x. And then you let dy dx equals to 2. Therefore, this differentiator equation equals to 2. You solve for x. Now, how do you solve for x? Remember, ln x is just log ex. So if that is the case, then e to the power of 1 gives you x. Logarithms. So this is your logarithms basics. Then you get x equals to e to the power 1, and then x equals to 2. So that means if x equals to 2, then you sub back inside your original curve over here, because, you know, like x equals to 2 still lies, fundamentally it still lies on the curve y equals to x ln x. So if you sub back in, you'll get the coordinates of y. And we know that ln e is just 1, because it's just log e. It's just 1. So you get y equals to e. Therefore, the coordinates is p, e, like p. Yeah. Then I. So they say the normal to the curve y equals to x ln x at p. So imagine, right, this is your p point. Your tangent is here, and then your normal. So what is this normal? This normal is perpendicular to the tangent. And in coordinate geometry, what did we learn? We learned that two perpendicular lines, when you multiply the gradient together, so if this is m1, this is m2, m1 times m2 gives us -1. So if you want to find the gradient of m2, you just take -1, divide by m1. So in this case, of m1 is 2, right? The gradient of the tangent is 2. So anyways, the question wants us to find the coordinates of Q, or they want us to show that the coordinates of Q is k bracket e plus 2. And Q is the point of intersection between the normal and the line y equals to 2x minus 3. So this is your basic coordinate geometry, where you let one line equal to another line to find the point of intersection. But more importantly is, how can we find the equation of the normal? So this is where, once you figure out your gradient of the normal is -half, then everything here onwards is just coordinate geometry. How you find equation of the line? You can either use y minus y1 equals to m bracket x minus x1, or you can just use y equals to mx plus c. Either ways, the m is the gradient. And then this y1, x1 refers to the coordinates of any one point on the curve. Then that's how you just sub in. Whereas for this, it's a little bit more steps. You need to sub in the coordinates of the points over here to find your c value. Then after that, you regross, and then you get y equals to mx plus c. So if you use this step, you still need to find your c value. Then you put back inside. Then you regross everything. But if you use y minus y1 equals to mx minus x1, you can straight away just find your y equals to mx plus c in this form. But up to you, whichever you're more comfortable with. So now we found out our equation of the line is y equals to half x plus 1.5 e. And then you have another line that is y equals to 2x minus 3. So if you want to find the point of intersection, you just let two lines equal to each other, and then you solve for the value of x. Right? So this is the first line, this is the second line. You let them equal to each other, and then you solve for the value of x. So getting to this point shouldn't be much of an issue for you, right? But note that the question wants us to express in the form of k bracket e plus 2, which is not this. So we know that we need to make 6/5 to become 2. So how can we do that? We factorize out 3/5. Because 3/5 times e gives us 3/5e, and 3/5 times 2 gives us 6/5. But how do you know whether it's 3/5, right? You just take 6/5 divided by 2. You get 3/5. And then, yeah, that's how you know what to factorize out. So that's your answer, where k is 3/5. Just like that. And then, that's 8 marks. Okay, trigonometry, question 10. This is half trigonometry, half, like part I is trigo, and then II is is differentiation. That's why in differentiation, it's usually they test like different chapters together. They either test like quadratic with quadratic with differentiation, trigo with differentiation, or sometimes they even like include weird topics like surds inside differentiation, and anything is possible. But either way, question 10. Now you have this PQRS, right? One look at it, you know it's a trapezium because you have one pair of parallel sides. And then the lengths are such that PQ is 20, RS is 20, QR is 30. And then the angle here is theta radians, and then here is theta radians as well. Oh, one thing to note is that every time when you are dealing with angles when you're dealing with angles or like differentiating angles in trigo, right? Your theta must be radian. It cannot be degrees. So always make sure when you differentiate it, you're dealing with radians. You cannot use degrees in differentiation. If not, you won't be able to compute. For example, if you have, like, let's say, they ask you to differentiate sine 60 degrees, like how are you going to differentiate this? Right? You have to change it to sine like pi over 3. Okay, anyways. Now, they say show that the area of the cross section is given by A equals to, whatever this is. So, two ways you can do this. One, you know that this is a trapezium because there are two pairs of parallel sides. One pair of parallel sides, like that. So the area of trapezium is just half times sum of parallel sides times your height. Right? So straightforward. The sum of parallel sides is QR plus PS. QR plus PS. This is the sum of parallel sides. And then the height will refer to this. So that's one way. Or another way you can do is to just break it up. You take this area plus this area plus this area. So you take the area of the two triangles plus the area of the rectangle at the center, which is fundamentally what a trapezium is, right? A trapezium is made out of two triangles and one rectangle at the center, or maybe a square, right? We don't. Okay, so first things first. I knew that here is 30 also, because here is 30, so here is 30. So all I needed to do was to find the length over here and this length over here. And since this side is 20, and since this side is 20 as well, and since this is theta, and this is theta as well, I know that this side is the same as this side. Exactly the same. So I just needed to find what is one side like that. Then I can just multiply by 2 and then I get the other side already. So AQ, which is this over here, is exactly the same as this, right? Same length. So the first thing I did was to go back to my basics, my E-math basics, Tuakaso, because I wanted to find the adjacent and I knew the hypotenuse. So Tuakaso, I knew the adjacent. I don't know the adjacent. I knew the hypotenuse. I knew the angle. But the angle is theta lah. So in that case, there's something for us to work on, which is theta. So I wanted to express A in terms of H and theta. Therefore, I chose cosine theta equals to A over H, which is AQ over 20. So you cross multiply, you get AQ is 20 times cosine theta, which makes the overall length PS. So this entire length over here, this whole entire length over here is just 20 cosine theta plus 30 plus another 20 cosine theta. So overall, you get this. Then the last thing to find is the height, correct? Because now you know the sum of the parallel sides. So the last thing to find is pretty much the height. So how can you find the height? The height is PA. So is this all. So again, it goes back to your Tuakaso. Now you want to find your opposite. You know your hypotenuse, and you know your theta over here. So therefore, you will do your Tuakaso again. Sine theta is O over H. So PA is just cross multiply 20 sine theta. Therefore, your overall area is just half times the sum of parallel sides, right, times the height. then you just multiply everything. Now, to note, when you come to this point, you get 400 cosine theta cosine theta. And the final answer wants you to express in terms of 200 sine 2 theta. So this is where you will need to make this shift, where you factorize out the 2 sine theta cosine theta, because you know that sine theta equals sine 2 theta equals to 2 sine theta cosine theta, right? And that's why you have to do that, like you have to factorize out. If not, you wouldn't be able to get this final answer over here. And then conclude it, show. So this part is just purely trigo and should still be manageable. It's 4 marks. So you should be aiming to complete it at least within 6 minutes, including checking. So you time yourself accordingly. Okay, so now they say given that theta can vary, find the value of theta for which the trout can hold a maximum amount of water. So now we want to find the value of theta when A is maximum, right? Because when the area is maximum, then the trout can hold the maximum amount of water, because the area is the largest. So that is where we need to find dA d theta. Why do we need to find dA d theta? Because we want to find the maximum value. And we know that maximum value is a stationary point. So we differentiate A. Sine theta becomes cosine theta. Sine 2 theta, first thing, follow the format PIT. Is there power? There's no power. Inside, we differentiate the inside first. So 2 theta, when you differentiate it with respect to theta, it becomes 2. And then trigo, that means you differentiate sine as its own, it becomes cosine 2 theta. Then now you combine everything, you get 600 cosine theta plus 400 cosine 2 theta. Then for stationary values, dA d theta equals to 0. That means, whatever you found here equals to 0. And now from this point onwards, you still wouldn't be able to solve it, because your angle here is theta, and then your angle here is 2 theta. That's why you need to change the 2 theta into a singular angle as well, so that your variable here is your variable here. And then you can regross it and it comes like that. So at this point, you realize that you have an equation that looks like ax squared plus bx plus c equals to 0. Right? This becomes a quadratic equation. So once you realize that this is a quadratic equation, you realize that cosine theta can have 2 values, right? Plus minus. Therefore, cosine theta, you will follow the quadratic equation, right? X equals to negative b plus minus b squared minus 4ac over 2a. So a very good presentation tip will look like that, where you define clearly what's your a, what's your b, what's your c. And then once you define it, it becomes easier for you actually, because you can just sub inside your quadratic equation. And just key this into your calculator, make sure you are keying properly, and then you get these 2 values. But now, okay, so the differentiation part is done already. Now it comes back to trigo. So you know that theta, which is this over here, is acute, right? For number 1, is acute. And since it's acute, it is between 0 degrees, x, and 90 degrees. Or in this case, it's between 0 and pi over 2. That means what? It lies in the first quadrant. It lies in Q1. So naturally, since it's negative, you'll reject this. But there's another reason why you'll reject this also. And that's because for cosine theta will never be smaller than negative 1. Or neither will it be bigger than 1. Right? You know your cosine graph. This is your cosine graph. Oops. Here is 1. Here is negative 1. It can never ever intersect this line, negative 1.1. Right? just cosine theta alone, it will never intersect. So that's another reason for you to reject it. Therefore, moving forward, you know that cosine theta can only equals to 0.42539 . So you solve for theta by bringing the cosine over, so it becomes cosine inverse. And therefore, theta equals to 1.13 radian. But this is not enough, because the question wants you to show that it is indeed the maximum, like A is the maximum, right? So up until this point, you only prove that theta is a stationary point. Okay, you only prove that when theta is 1.13140 radian, it's a stationary point, because dA d theta equals to 0 ma. But you still haven't proved that it is the maximum value, because stationary point can be maximum, minimum, or point of inflection. So you need to take one step further to do this, to check. So you can either use d square A, d square theta, d square A, d theta squared, or you can use your first derivative test. In this case, we use the second. Now, you might be wondering, should I use first? Should I use second? The answer is, it really depends on the question. And also, it also depends on your preference. Because if your dA, d theta is easy to differentiate again, then it might serve you, it might serve you better to just differentiate it again instead of drawing out the table. But if you want to just straight away draw out the table to solve this question and essentially prove that theta, when theta is 1.13, is a maximum, where is negative, then by all means, right? It's as long as you prove that it's a maximum point. So in this case, we use second derivative test, and we differentiate our dA, d theta again. So we differentiate this again, and it's the same thing, right? Cosine becomes negative sine theta. Cosine 2 theta becomes follow the sequence PIT. Is there power? There's no power. Inside, okay, you differentiate the inside first, so it becomes 2. Then you differentiate the trigo, T. So when you differentiate cosine, it becomes negative sine 2 theta. So therefore, you get this. And now you suck in your theta value, and you realize that overall you get negative value for your d square A, d square A, d theta square. This will be theta. Therefore, since is negative, it's a maximum value. So how do you remember this, right? Because I know it can be a little bit tricky. D square, okay, when you say d square A, d square theta is negative, right? Just think of it as the gradient is decreasing, right? Because d square A, d theta square is negative. So the gradient is decreasing, then you can think of it as it's decreasing from positive to negative. That means your gradient is going from this to this. And then you can just put a line here. Therefore, it looks like a maximum point. Then the converse, if it's positive, that means gradient is increasing. That means you are going from negative to positive. That means you're going from negative to positive. Then you join the two lines together, you get a graph that looks like that. So this is a minimum point. But if d square A, d theta square is 0, then you cannot tell anything. Then you need to use your first derivative test to determine what's the nature of it. So yeah, that's the answer for 10, trigo and differentiation. Okay, 27. So this is a pure differentiation question, right? 7 marks. And the reason why it's 7 marks is because it's quite long now. As in the equation is quite long, but as long as you're not careless, you should be fine. So this is your original equation. Then they want you to differentiate it one time. dy dx. So how do you differentiate this? This is u, v. So you get u, v prime, v, u prime, right? You add them together. So when you differentiate x squared, you get 2x. And then when you differentiate e negative x, this is the same as fx. So you get f prime x times e fx. So your f prime x in this case is just -1 because your fx is negative x, therefore your f prime x is -1 because x becomes 1. So you just combine everything together, you get this. Right? From this step to this step, I factorize out the e to the power of negative x. And then to get the square y dx square, you just differentiate one more time. So it's round 2 of the same thing. This is what? U, v. So you get u, v prime, v, u prime, plus. Then you repeat the process, but just be very careful. And then pretty much once you're done, right, you can just combine everything into one equation. So from here onwards, so basically, when you differentiate 2x minus x squared, the 2x becomes 2, and then the x squared becomes 2x, right? Then when you differentiate the e to the power negative x, it's the same thing over here. So you get this. And then you combine everything, but what I did was that I factorized out the ex, e to the power negative x, for good reason. And that is because later on, when you sub them in, right, so you sub your d square y dx square, and then you sub in your dy dx over here, you realize that your final answer is k, of which k is a constant. So there's no more variables in your k really. It's just a constant, it's just a number. So the reason why we factorize out is because we know that we have to use ex later on. We have to strike away ex essentially. And what is the only thing that will strike out ex without leaving a remainder? E to the power of negative x. Right? When you take ex multiplied by e to the power of negative x, you get 1. So that's the only thing that will strike it out. That's why we factorize out e to the power of negative x. So that later when you multiply it, it's gone. Right? When you multiply it, it's gone. And now since that it's gone, you can just combine the rest of your other like terms together. And just nice, x squared, they cancel each other out. 4x, they cancel each other out. Thus you're left with just 2, which checks out because 2 is a constant as well. So therefore, k is 2. And it's just like that, you got 7 marks. So it pays to get like used to differentiating, or like at least try to remember your differentiation formulas. Okay, next. So we have the curve y equals to 6 over square root x plus x has a minimum point of m. M is the minimum point. Show that the coordinate of m satisfies x cubed equals to 9. So 2 things. We need to find the x coordinate of m. And number 2, we need to show that it satisfies the equation x cubed equals to 9. So right off the bat, I know that I have to differentiate y. Why? Try differentiate y is because I want to find the coordinates of the minimum point. And a minimum point is a stationary point. So I will have to differentiate this. But of course, I don't want to, maybe it's up to you guys, your personal preference. If you like to differentiate in this form, then you go ahead. But I like to differentiate in this form. So it's really up to you. That's why what I did was that I changed this to become product rule. Right? So this one goes back to your basic law of indices. 6 over square root 3, square root x equals to 6 times 1 over square root x. And a to the power negative 1 is 1 over a. So you work backwards. So it's just 6 times square root x to the power negative 1. And then square root itself is power half, right? So it becomes 6 times x to the power of half, power negative 1. Therefore, it's just 6 times x to the power of negative half. So that's how you derive this, plus x. Then now you dy dx. So chain rule. Power, differentiate the power first, then you differentiate the inside. So this one also applies to, the PIT also applies to this. It's just that in this case, there's no trigo. But there is a power and then there's an inside as well. So you differentiate power and inside without the trigo. And then of course, when you differentiate x, you get 1. Right, that one nothing much to say. So therefore, you get this. Make sure when you differentiate, you don't miss out the negative in the half, right? Make sure the negative is still there. Then essentially you combine everything and then you should get this. So now your dy dx equals to 0. So we are trying to find the minimum point. Therefore, we need to let the dy dx equal to 0 and we solve for x. So you realize that this square root x cubed equals to 3. So you remove the square root, you need to square this side, right? Then you get x cubed equals to 9. And therefore, bracket shown. Proven. So that's what the question wants us to do anyways. Then in II, they say point A and B lie on the curve, and the tangents to the curve at point A and B meet point P. So you can sort of visualize this, right? Our curve, let's say, is like that. This is our 2 points here. This is my tangent, they meet at P. So this is something like that, right? And they want us to determine whether the x coordinate of this is greater or lesser than the x coordinate over here. So how do we do that? First things first, in order to find the coordinate of P, we need to know the equation, the equations of lines of the tangent at A and B. So how do we find equation of a line? We need 2 things. We need gradient and we need 1 pair of coordinate on the line. Gradient and 1 pair of coordinates. That's why to find gradient, we will use our dy dx equation. And how we do that? We know that point A is 1, 7. So we sub x equals to 1 inside of dy dx, we get -2. And from here, we can just find the equation of the tangent by subbing in m is -2, and then you sub in the 1 over here, and you sub in the 7 over here. 1 pair of coordinates. Therefore, you get that x is -2x plus 9. And then you repeat the process for b, right? You sub in, now in this case, b is 4, 7. So you sub in x equals to 4 inside here. So you get dy dx is 5 over 8, which is the gradient. Then you sub inside here. And then here, you sub in 5, and 4. Then here you sub in 7. Then you essentially get your equation of the line. So to find the coordinates of P, all you have to do is to let the 2 tangents, tangent 1 equals to tangent 2. So this one goes back to your coordinate geometry already. Now when you let these 2 lines equals to each other, you're able to find the point of intersection. And in this case, they intersect at x equals to 1, 5, 7. So now then you compare, right? This is 1, 5, 7, which is 1.7, 1, 4, 2, dot, 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 dot. And the x coordinate of m, it occurs over here, x cubed equals to 9. Therefore, x is cube root 9, which gives us this number. And then you can, compare it. Since this is lesser than this, which this one represents, belongs to P, and then this belongs to M, the x coordinate of P is less than that of M. So this is how you do question 20. Okay, question 30. So a particle moves along a curve, y equals to ln bracket 3x minus 1, such that the y coordinate of the particle is increasing at a constant rate of 0.06 units per second. This is chain rule. Immediately, you see this, you know it's chain rule already, right? Because you have an equation that the y is related to x in this manner. But at the same time, y is increasing at its own rate, where x is also increasing at its own rate. Because you read the question, they say they want us to find the rate of the increase of x. So how immediately once we see this, how can we link dy dt with dx dt together? We use chain rule. Dy dt equals to dy dx times dx dt. And how do you know? You visually, these two strikes each other out. Visually, which gives you this. Conceptually, that's wrong, but visually, you know, this is how we check that we are correct quickly. So given that dy dt is 0.06 as given by the question, our only goal now is to find out what's dy dx. That's step 1. Step 2, we sub in x equals to 7 inside dy dx to find dx dt. So that's exactly what we did here. Dy dx is just 3 over 3x minus 1. Why? Because you're differentiating f prime x, you get f prime fx, so you get f prime x over fx. So f prime x is basically just differentiating 3x minus 1, which you get 3. And then fx is just the remaining, is exactly the same, it's just 3x minus 1. So you get dy dx is this. So now your equation looks like that. 0.06, which is dy dt, as given by the question, equals to dy dx. And this is our dx dt. And we want to find the value of dx dt when our x over here is 7. So you sub in 7 over there, and you solve for dx dt. And then you get that dx dt is 0.4 units per second. This is a very, very standard type of chain rule question, right? Probably came out in your prelim as well. But fundamentally, it's like that. It's exactly like that. It's always the same. It's just finding out what is 2 of them so that you can find the unknown. Therefore, when x equals to 7, your dy dt is 0.06, and your x is, dx dt is 0.4. That's the answer over there. Then in BI, they say the equation of a line, of a curve, is y equals to 8 minus bracket 2x plus 1 cubed. Explain why it has only one stationary point. And why is this a point of reflection? So immediately when I see this question, I'll think to myself, okay, how can I prove there is a point of reflection? I need to draw my first derivative table, because that's the only way you can show it's a point of reflection. You cannot use second derivative, right? Because d square y dx square, when it equals to 0, you cannot prove that it's a point of reflection. You need to verify it, you need to use your first derivative test. So that's for the second part. Now, how do we explain why it has only one stationary point? So if it has only one stationary point, that means there should only be one value of x, or essentially there should only be one solution of x when we let dy dx equals to 0. So that's what we did. First things first, we let dy dx equals to 0. We find what is dy dx. We differentiate this. 8 becomes 0. So all you have to do is to differentiate negative bracket 2x plus 1 cubed. Now, differentiate this, bring down the 3. So you follow PIT. There's no trigo here, so you just differentiate power and inside. So power is 3. You bring down the 3, you minus 1 to the power, you get 2. And then you differentiate the inside, which is essentially just here. You get 2. Therefore, your answer is negative 6 bracket 2x plus 1 squared. Then now you let dy dx equals to 0. You solve for x. But then you realize that x has only one value, which is repeated. So therefore, you prove that there's only one stationary point because there's only one value of x that satisfies the equation dy dx equals to 0. And how do you prove it? You draw your first, how you prove is a point of inflection, you draw your first derivative test table. So pretty standard, right? This is the center value is always your value when dy dx equals to 0. Then you, on your left, you just minus 0.1. On your right, you just plus 0.1. Then whatever value here, you get over here, you just sub back inside your dy dx. Just key it to your calculator. And then over here, you indicate whether it's negative or positive. So in this case, both sides negative. That means since both sides are negative, your tangent is sloping downwards. Therefore, your point of inflection looks like that. Going downwards, flat, going downwards. So that's how you show it's a point of inflection. Then they want you to, the last part, find the coordinates of the stationary point. Since you know the stationary point is x equals to negative half, you just sub it back inside your original equation y equals to ln bracket 3x minus 1. Or you sub back inside your dy dx. But in this case, you don't have to, like, just actually not this, that's part A. You sub back inside your y equals to 8 minus 2x plus 1 cube. Yeah, don't sub inside your dy dx, you will get nowhere. In fact, you'll just get back 0. But now you just need to sub back inside your original curve. Then you get 8. Therefore, the answer is negative half 8. Okay, very good. Next. Okay, 37. So, given that y equals to a ex plus b e negative x, and that dy dx plus 4y equals to ex minus e to the power negative x, find the value of a and b. Okay, so this one is just simultaneous equation, right? To find the value of a and b, you need to essentially sub dy something into dy dx. So this is your equation that you're going to sub everything inside. Your y is already here. So later you sub this in. So what's left to do, or rather what's all that's left to do for now, is to differentiate to find what's your dy dx equation so that you can sub inside here. So how do you differentiate this? A is a constant, B is a constant. So you don't need to differentiate a scalar multiple. So all you have to do is to just differentiate e 2x and e negative x. When you differentiate e 2x, you get e 2 times e to the power of 2x. And when you differentiate e to the power negative x, you get negative 1 times e to the power negative x. So once you do that, you sub everything inside here together, all together. So this over here is your dy dx. This over here is your y, and then the rest is whatever the question gave you. So now you expand everything. And what do you realize? Once you expand everything, you can combine all of the a together. You can combine all of the b together. And that should result you with this 6a e2x minus plus 3b e to the power of negative 2x. Right? And therefore, okay, this is 2. Let me adjust this. This is 2. And therefore, if you compare coefficients from your left-hand side and your right-hand side, you get 6a is 1, therefore a is 1, 6, and then 3b is negative 1, because 3b and then negative, therefore b is just negative 1. Show. Actually, you don't need to show, like the question asks you to find. But that's pretty much how you do it. For, yeah. Okay, question 44. Okay, so now you have a trapezium. Again, trapezium means right now, immediately. And yeah, that's pretty much it. So now the question says, show that the perimeter is given by this P equals to 22 plus 12 cosine theta plus 12 sine theta. So you know that this is 12 and you know that this is 5. So all you have to do is to find out what is this, find out what's this. Now, since Kn and Lm are parallel to each other, that means that this point that goes down all the way until here is perpendicular and it forms a right angled triangle. So with that, we can find this length over here by associating this length with this length because they are exactly the same. And since this is a right angled triangle, we can use Tuakaso to find the length of OM. So O is this point over here. This is O. So going back to your trigo basics, this one is your opposite. This is your hypotenuse. This is your adjacent. Therefore, it's just cosine theta equals to opposite over hypotenuse. Because this is what you're trying to find. This is what you know, which is 12. So therefore, ON is just 12, just cross multiply 12 cosine theta. And then, now, the next thing to find is essentially what is this length, right? Because now you have found this length already, and you know that this length is 5, because this length over here is directly opposite this length. So the only thing left to do is to find out what is this length over here, which also goes back to Tuakaso, right? So with reference to this is your adjacent, this is your hypotenuse. Apologies, this is your A. This ON is actually referring to this. Yeah, but it's all the same. It's just Tuakaso. So just now, what I did was that I found this A over H. Then now I find what's this, which is O over H. Your O is your unknown, your hypotenuse is known, which is 12. Therefore, OM is just 12 times sine theta, just cross multiply. So now you can pretty much find your entire parameter. You just take everything, add together, and you will eventually end up with this, which is what the question wants. So this is still trigo. Then II is testing you on R formulae. So they say, find the value of R when 12 cosine theta plus 12 sine theta is expressed as R cosine theta minus alpha. So now they want us to express it in this form. So don't you think so much, because your R is always just a squared plus b squared squared. So you just take, this 12 squared plus 12 squared, which you can deduce as 2 times 12 squared, because there's 2 12 squares. So when you square root 2 times 12 squared becomes 12, and then 2 becomes square root 2. And on the other hand, to find your A or your alpha, you just take tangent inverse B over A, of which is 12 over 12, which gives you 1, and tangent inverse 1 is always just pi over 4. That means this is as such. Just sub it in. And therefore, your parameter is this. Now, we know that in order for a parameter to be the maximum, right, the largest parameter possible, we need cosine this value over here to become 1, right? Because for any cosine graph, or rather a normal cosine graph, here is 1, here is -1. So the maximum value of a cosine graph is 1. Therefore, we need this to equals to 1. So the maximum possible value actually happens when cosine bracket theta minus pi over 4 equals to 1. But no, we are not required to solve for theta. They just want the maximum value. So we just let this one equals to 1. 1. And therefore, this is our answer over here. Then in III, they say, show that the area is given by this. So area of a trapezium is just half times sum of parallel sides times height. And in this case, the KL is the height. And then this is the sum of parallel sides. So you just take the sum of parallel sides, right? And your LM is 5, as you see over here. And then the other side is just 5 plus 12 cosine theta. That's what we found earlier. And then your height is just KL, right? So it's 12 sine theta. So you just multiply everything together. And then you'll realize that cosine times sine is sine cosine. But our final answer is in the form of sine 2 theta. So you need to use the sine 2 sine theta cosine theta equals to sine 2 theta rule to derive this. And then you get this. So short, right? That's how you do it for this part. And then the last part, then that's where the differentiation comes. So this whole entire chapter is just trigo. Trigo, then the last part is differentiation. So they say the maximum area of the plate is obtained when theta, which can vary, gives us a stationary value. So essentially they want us to find the value of theta when A is maximum. So for any maximum values, we know that it's a stationary point on the curve A. So that's why the first thing we do is to let dA d theta equals to 0. To find the coordinates or per se coordinates per se, or to find the value of theta when A is stationary. So we differentiate and we get dA d theta first. So when you differentiate 60 sine theta becomes cosine theta. 36 sine 2 theta PIT. Power, there is no power at all. Inside refers to 2 theta becomes 2. Right? Differentiate 2 theta, it becomes 2. Then trigo means the whole thing over here. So sine, when you differentiate it, it becomes cosine. Therefore, this is your answer. Then you let this whole entire thing equals to 0. But as you know, one of the earlier questions that I went through, this theta and this 2 theta, they are different things. So we cannot associate them together. That's why all need to change to singular angle. And how do we change all to singular angle? You remember, or actually this is in your formula sheet. Cosine 2 theta equals to cosine square theta minus. Right? So you change it into this form. Then you make sure when you expand it correctly. And when you regross everything, you realize that you get 12 cosine square theta plus 5 cosine theta minus 6. Then this is where you realize that this is actually a quadratic equation. Okay, carrying on. Apologies, my Wi-Fi died just now. Okay, so as I was saying, this is exactly like your quadratic formula. You just submit your values, and then you realize that if you key your calculator properly, obviously there's two values because there's a plus and minus sign. You will end up with this value and this value. But this is where we need to think critically because theta, right, your theta in this case is acute, right? Fundamentally, it's acute. You can see for yourself. So since cosine theta is acute, by ASTC, it lies in quadrant 1, right? It definitely lies in quadrant 1 because it's acute. Therefore, cosine theta must be positive. So we will reject this because the negative over here represents that it lies in either here or here. But we know that it lies here. So we reject the negative value. So moving forward, theta only has one value, which is the acute value. And how we do that is just like finding your basic angle. So you bring your cosine over, becomes cosine inverse. Then you get this. So your answer is 1.01 radian. But this is not enough, right? Again, this is not enough because we need to show that it is a maximum area as well. So if you miss this step, you'll lose 1 mark because you never prove that it's a maximum value. And how we do that? Two ways: first derivative or second derivative. But in this case, I use second derivative because just based off experience alone, right? Every time you differentiate a trigonometric equation, usually it's very hard to get zero lah. Yeah, especially if like your theta, right, is like this type of non-terminating angle, like dot 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 dot. Usually it's very hard for you to get this d square a d theta square equals to zero lah. So using second derivative test shouldn't shouldn't waste your time. So you differentiate again, and then you will end up with this. Right, just use PIT and then you'll be fine. And then when you sub theta in, you get d square a, the theta square is negative. And since it's negative, you know that the theta is decreasing. So it's going from positive to negative. That means it's going from positive to negative. And you connect them together, you get maximum point. Okay, so that's pretty much it. Then now, okay, let me see what questions we have. We have done up until here, so we are left with 55. Okay, let me take it down. We are left with 55, 51, 52. Okay, left with 51, 53, 55, 59, 55, 59, 61, 64, 65. Okay, if I cannot finish all of this by 4 o'clock, I'll just, like the previous session, I'll just record them and upload them by the end of the day. 65. Okay, can. Okay, so now let's go back to question 51. Question 51. Okay, can. 51. Okay, now from this point onwards, I'm just going to do it live before you. So I might take a little bit more time, but at least you get to see my thought process. Okay, question 51. You have a container and then a cone essentially. And then the cone looks like that. So if I'm going to draw this out, it looks like that. This is your cone. This one. This whole thing here is 25 cm. Here is x cm. Here is therefore 25 minus x. Right? And then here to here is 15. And yeah, that's pretty much it. Okay, so what other things do we know? The container is initially empty. When t is 0, the liquid is allowed to flow in through a small hole at the vertex. So the liquid flows in here. And after t seconds, the height is therefore just t 25 minus x. And the volume is v cm cubed. So part I, they say show that v is 3 pi brackets 625 minus x cubed over 25. So we know that the volume of a cone, right, is 1/3 pi r square h, right? So the r in this case is 15, and then the h is, they want us to show that the volume of the liquid. So they want us to find the volume of this liquid. Okay, so how do we find the volume of the liquid? Volume of liquid equals to volume of cone minus away the volume of empty cone, right? So essentially you find the area of the whole cone, then you minus away this blue part, then you get the red part. So right from the beginning, volume of entire cone equals to 1/3 pi r square h, which is 1/3 pi 15 square h, 25. Right, and let me just calculate this. You all can feel free to do this question with me as well. So it's 15 square times 25 divided by 3. So it's just 1875 pi cm cubed. Okay, then now we need to find this over here. But obviously to find this, we also need 1/3 pi r square h. So we need to figure out what the h is x, but we need to figure out what's the radius, right? And what is this radius over here? So how can we do that? Actually, we can do that using similar triangles. And why is that so? Because this triangle over here is inside this bigger triangle. Right? So, okay, it's inside this bigger triangle. So they have the same shape, it's just different size. Therefore, they are similar triangles. And since they are similar triangles, we know that the ratio of the corresponding sides are equal. So if we want to, so if this is x, and this whole thing is 25, that means x over 25 is the same as the radius over here compared to this radius over here, which is 15. So 15 over r, right? And therefore, if we cross multiply like that, so I'm going to write at the bottom here, we get 25r is 15x, right? And therefore, r is just 15 over 25x. Now, why do we want to express r in terms of x? Because in our final answer over here, there is no r, there's only x. So when we eventually sub the r, right, inside here, we need to put it in terms of x. All right, so therefore, the volume or smaller cone is just 1/3 pi bracket 3 or 15 over 25 is 3 over 5. So this is 3 over 5x. 3 over 5x square times h. h is x as well. So as a result, you will get 1 over 5 pi x cubed. No, not 1 over 5. You will get, you get 1 over 5. 1 divided by 3 times 3 over 5, you get 1 over 5. So now, therefore, your V equals to 1875 pi minus 1/5 pi x cubed. Therefore, our final answer, we factorize out the 3 pi. So we factorize out the 3 pi over here, we should get 1875 divided by 3, we get 625. And then we factorize out the 3 pi, so we take this divided by 3 pi, we get x cubed times 1 over 25, so it's divided by 25. And that's the answer of that. So we just bracket show. Okay, so that is part I. Still fairly straightforward. Now I, given that the rate of flow of the liquid, so our dv dt, our rate of flow of liquid, okay, is kx squared cm cubed per second, where k is a constant. Find an expression of dt dx. Okay, can. So now our equation is, let's recap our equation. V equals to 3 pi 625 minus x cubed over 25. Now the question tells us that dv dt is kx squared cm cubed per second. And now we want to find what is dt dx. So if we want to, we know that this one is related to this. And of course, we know that the dx dt, there's also a dx dt, because as when the volume changes, the x will also change over time. So this is one, this is two, and then of course we have our third one, which is dv dx. So now the question comes, how can we link all of them together? We know that dv dt is dv dx times dx dt, because visually it cancels each other out and then you get this, right? But I know our final answer is dt dx, which we can get once we solve what is this. Then to get to this, we just take 1 divided by dx dt, we get this. So yeah, that's the analogy. So now we just need to figure out what is this. We know that this is already kx squared. So now we just need to find out what is this when. Okay, no, we just need to find out what's this. So let's differentiate our v equation first. So dv dx is, okay, let me write here. dv dx is, the 3 pi is a scalar unit. So is 3 pi. Okay, let's expand it first. This one is just 625 times 3. So we get 1875 pi minus 3 out of 25 pi x cubed. Right, so now we differentiate that. So 1875 pi becomes 0. So over here it gets negative 3 over 25. This is a scalar multiple. This is the scalar multiple, right? And then you bring the 3 down, you get x squared. So as a result, you get negative 9 over 25 pi x squared. So now we can essentially link everything together. So kx squared equals to negative 9 over 25 pi x squared times dx dt. Therefore, dx dt is kx squared divided by negative 9 pi x squared over 25. So dx dt is therefore just divide, so you get 25 kx squared over pi x 9 pi x squared negative, right? And if you simplify this, you can cancel out the x squares. You get negative 25k over 9 pi. Therefore, dt dx is 1 over dx dt, which is 1 over negative 25k over 9 pi, which gives us negative 9 pi over 25k. That's the answer for II. Okay, so from here onwards, the next step would be III. So they say the liquid was allowed to flow for 72 pi seconds when the height reached 12 cm. By expressing t as a function of x, find the value of k. Okay, so this part is actually integration, but we haven't touched on integration yet, so as I haven't go through integration yet, so we'll KIV this one first for integration chapter. Yeah, because all you have to do is to integrate this. You have to integrate this because now this is dt dx ma. So you integrate this, you get t equals to integrate dt dx dx. Then you essentially will get the t equation. Then you sub the values of t inside to find the value of k. But this one will KIV for integration once I go through it. Okay, now that being said, the next question will be 53. Okay, question 53. So you have a rectangular field, just like that. Okay, wait, no, this is not rectangular. This is a rectangular field. And this is B, this is C, this is A, this is D. This is 50, this is cut here, cut here, cut here. This is 80, this is X, this is 2X. Okay, now they want us to show that the area A is represented by x squared minus 40x plus 2000. Okay, so how do we do that? Essentially, all we have to do is to find the entire area, right? So, as in we need to find this P. We need to find this area. Because the triangular plot BPQ is to be planted with maize. So we need to find this area. So we find this area, we find the area of the entire thing, then we minus away this one, we minus away this one, we minus away this one. Right? Fairly simple. So first things first, this, okay, I will just write over here. Your PD is just 50 minus x cm. So this is 50 minus x cm. Therefore, your area A, B, C, D at first is just 80 times 50, right? Which should give us 4,000 meters squared. That's the entire area. Then next, find area of triangle ABP. So it's half times 80 times x. So you get 40x meters squared. Then next, find area of triangle PQD. Half times 2x times 50 minus x. So we get 50x minus x squared meter squared. Then the last one, area of triangle BCQ. So you get half times 50 times, over here is 80 minus 2x. So we times 80 minus 2x. So as a result, you should get 25 times 80, get 2000 minus 50x meter squared. Therefore, area is 4000 minus 40x minus 50x minus x squared minus 2000 minus 50x. And that should give us, so 4000 minus 2000, then we have minus 40x minus 50x plus 50x minus x plus x squared. So this should give us 4000 minus 40x plus x squared, which therefore is just x squared minus 40x plus 4000. So A bracket shown. Okay, then in B, they say given that x can vary, find the stationary value of A. So for all stationary values, dA dx is 0. So we need to differentiate our A first. How do we differentiate A? So dA, dA dx is 2x minus 40. Oh yeah, that's it. Yeah, that's it. 2a minus 40. So we let dA dx equals to 0. So 2x minus 40 is 0. 2x is 40. Therefore, x is 20. So this is our stationary value of A. No, this is not our stationary value of A. We still need to sub back in, right? But this is our value over here. When x is 20, dA dx is 0. So sub x is 20 into our initial equation A. So A is 20 squared minus 40, 20 plus 2000. And this should give us 20 squared minus 40 times 20 plus 2000. So give us 1600. Right? But this is not enough, right? Because we need to determine the nature. So looking at this over here, I would say just differentiate this one more time, because you know that this one will become 2. Then this one will become 0. So you will still be positive. You can immediately tell it's positive. So to determine the nature of x equals to 20, oh, okay, don't even need to write this. You just say, just straight away do d square a dx square is 2, which is bigger than 0. Therefore, since d square a dx square is positive, a has when x is 20, A has a minimum value of 1600 meter squared. That's it. That's the answer for B. Okay, good. Next question, 55. 55 is integration. Okay, we skip this first. We'll do it the next session when we, when I go through differentiation. Okay, good. Question 59. Okay, you have a curve, and this is a quadratic curve. How do we know it's a quadratic curve? Because I see x squared. So points A and B lie on the curve and have x coordinates of k and 2k respectively. K is a constant, and k is between 0 and 7. So find the range of values of k for which the y coordinate B is greater than the y coordinate of A. Okay, so this is our original equation, right? 14x minus x squared. So when x is k, okay, never mind. For point A, when x is k, y is 14k minus k squared, which gives us 14k minus k squared. Therefore, A is k, 14k minus k squared. For point B, when x is 2k, y is 14 2k minus 2k squared, right? And this should give us 28k minus 4k squared. Therefore, B is 2k, 28k minus 4k squared. Then now they're saying that find the ranges of value of x for which the y coordinate of B. So the y coordinate of B is this one, and the y coordinate of A is this one. They say they want us to find the range of values of k when the letter is bigger than the initial. So therefore, for y coordinate of B to be greater than y coordinate of A, 28k minus k squared is bigger than 14k minus k squared. Then now we are going to our inequalities already. Just bring everything to this side. So therefore, wait, no, this is negative 4k squared. Yep, okay. So that means if we bring everything to this side, we will have 14k is 3k squared is bigger than 0. Right? And now let me check. 4k. Okay, so that means we factorize out the k, we get 14 minus 3k is bigger than 0. Right? So how do we solve this? If we look at our number line over here, here is k is 0 lah, right? That means if we let this whole thing equals to 0, that means k is 0, or 14 minus 3k is 0. That means 3k is 14, and therefore k is just 14 divided by 3. So here is 14 divided by 3, right? And essentially we want the values of k which are bigger than 0. Okay, let me just check. Y coordinate is bigger than this. Okay, that means when I bring the x this over, it becomes negative. Then when I bring this over, it becomes this. And then now I factorize out the k, I get this is bigger than 0. Correct. So that means it's here, and then it's here. Therefore, our answer is k is smaller than 0, or k is bigger than 14 over 3. Then B, they say explain why the gradient of the curve at A is always greater than the gradient of the curve at B. So now going back to this, y equals to 14x minus x squared. To find the gradient of the curve at A and the gradient of the curve at B, we need to dy dx, right? We need to find the gradient function. Therefore, dy dx is 14 minus 2x. So at point A, gradient of tangent equals to 14 minus 2k. At point B, gradient of tangent equals to 14 minus 4k. Right? So since 4k is bigger than 2, that means 14 minus 4k will be always greater than the value, no, 2k, greater than the value of 14 minus 2k, 14 minus 4k, right? So therefore, gradient will always be greater than the value of 14 minus 4k. Therefore, gradient of curve at A is always greater than that of point B, shown. All right, so that is how you do question 59. Okay, now moving on, let's go to question 61. Okay, question 61. For question 61, so we'll just wrap it up at question 61 today, then I'll send the rest later on. So now we have an equation of a curve, and this curve is a cubic equation, right, where a and b are constant. So they say show that y is always increasing if a square is smaller than 3b. So to show that for y is always increasing, we need to show that dy dx is always bigger than 0 for all values of x. So the first thing to do is to differentiate. So dy dx is just 3x squared minus 2ax plus b, right? This should be no problem. And that means this one must be bigger than 0 for all values of x. So how can we show that this equation is always positive? This is where we need to recap. Fundamentally, this is a quadratic equation. So since this is a quadratic equation, for any quadratic equation to always be positive means for all values of x. What does that mean? That means discriminant must always be negative. That means this curve can never be over here. It must never cut the x-axis. And since a over here is positive, therefore you know for sure it's this case. So our job now over here is to find the value of the discriminant first. So therefore, discriminant equals to b squared minus 4ac. And we will take reference to this. So negative 2a squared minus 4, 3b, which is just 4a squared minus 12b. And we know that is less than 0. So 4a squared minus 12b is less than 0. That means 4 bracket a squared minus 3b is less than 0. Right? And since discriminant is, oh yeah, okay, so since, okay, if a squared is lesser than b, that means if this is the case, then a squared minus 3b will be negative, right? Because you have, if this is smaller than this, that means smaller number minus bigger number will always be negative. And therefore, 4 bracket a squared minus 3b will always be negative. So since discriminant is negative, your dy dx, which is essentially this over here, is positive for all values of x shown. So this is how you solve this question, is by using discriminant principle for the dy dx. Okay, then in B, they say in the case where A is 8 and B is 10, find the x coordinate of each. So how do you essentially do this? Now, there are each of the 3 points of which the curve intersects the x-axis. So to do this, you need to first find out what are the 3 points of which the curve intersects the x-axis. So our equation is y equals to x cubed. Now we submit the value of a, so it's 8x squared plus 10x plus 4. Right? So now this goes back to our polynomials, right? Our cubic equations. And essentially what we need to do is to first guess what is a first factor of this, what's a possible factor. So let's just guess when x, let's say x equals to 2, y equals to 2 cubed minus 8, 2 squared plus 10, 2 plus 4. Right? And if you key this into your calculator, you should get 0, right? You should get 0. So therefore, our answer here is 0. So that means we know that x minus 2 is a factor of y. Right? And since we know that this is a factor of y, we can use this factor to find the rest of our other factors of this cubic equation using long division. 8x squared plus 10x plus 4, x minus 2. Long division, this one divided by this one gives us x squared minus x cubed minus 2x squared over this one bring down negative 6x squared plus 10x plus 4. This one divided by this one gives us negative 6x minus bracket minus 6x squared plus 12x. Minus it away, you get negative 2x plus 4. Negative 2x divided by x gives us negative 2 minus negative 2x plus 4 gives us 0. So therefore, y equals to x minus 2, x squared minus 6x minus 2. And now we just need to find a way to break this down into its 2 linear factors to essentially find the other 2 coordinates, x coordinates of the x-intercept. But now we look at this, right? We wouldn't be able to use this table method, right? I'm just looking at this and I know that I wouldn't be able to use it. So how do I solve this? I will use the quadratic formula. So therefore, x equals to negative 96 plus minus 96 squared minus 4ac over 2a. And I'll just key this into my calculator and I should get 2 values. So I get 6 plus square root 6 square plus 8 divided by 2. So my first value that I should be getting is 6.3166 dot dot dot, or x or equals to, then I just flip the sign and I should get negative 0.3166 dot dot dot. So these are my 2 possible x-intercept values. So therefore my answer is 6.32 3SF or negative 0.32 3SF. Therefore my x coordinates are, so this one is not differentiation already, this one is just polynomials. X equals to 2 comma negative 0.32 or 6.32. The end. Okay, so that is it for this point. And now we are just going to wrap up today's session, and next week I will just carry on with the other questions from the integration side. So I'm going to stop the recording. Okay, welcome back. Today we are going to go through the differentiation questions, but the entire TYS, right, they pretty much just group differentiation with integration and then they lump it under calculus. So that's why you will see that I've like handpicked questions that are relevant to us now, because so far we have gone through differentiation basics and applications of differentiation. So the questions that I chose today are especially just for the chapters that we have gone through so far. Then the rest we'll just go through when we have covered the basics of the chapter. Okay, so with that being said, here is how to do differentiation in your O levels. So right from the beginning, question 1. You see that a particle moves along the curve y equals to 2 minus 1 over x squared, such that the y coordinate is increasing at a constant rate of 0.03 units per second. So when you read the question and you see this phrase, immediately you can tell that dy dt is 0.03 immediately. So that is why I wrote it out over here. dy dt is 0.03. So now they want you to find what is dy. Find the y coordinate of the particle at the instant. So they want you to find the y coordinate when the x dt is 0.12 units per second. So the first thing to note is this. That's given by the question. And now we figure out what the question wants. The question wants this when dx dt is 0.12. So when you read these type of questions, the first thing you need to do is to figure out how can I link dy dt, dx dt, and dy dx. You need to first figure that out. And that's where your chain rule comes in, over here. So dy dt equals to dy dx times dx dt. How do you come up with this? Just make sure that visually this cancels out this. Then this will give you this. Although that is not how it works. Okay, this isn't how it works, but as long as you visually see it, then you know it's correct. So step 1 of any question is to figure out what's your dy dx. And how do you differentiate this? When you differentiate 2, you get 0, so it's nothing. So now you're just left with differentiating negative 1 over x squared. And negative 1 over x squared can be represented as negative x to the power of negative 2. So how do you differentiate this? Always remember power inside, pi, and then t. T stands for trigo. So it's power inside trigo. In this case, there's no trigo, so we'll remove the trigo. So power and inside. The first thing you do is to differentiate the power. So the power, you bring it down. You bring the power down, then you minus 1 to the power. So this is negative 2 minus 1. And then that's the power. And then you differentiate the inside. So the inside is this, which is just 1. That's why we don't write it. That's why your differentiated equation is 2 over x cubed. And that's why you will form this equation over here. So you'll sub it in. The question tells you dy dt is 0.03. And then the question tells you that dx dt is 0.12. So you just need to sub in dy dx is 2 over x cubed. And they want to find the value of x cubed when this is the case. So you just solve for x cubed, right? And from this point onwards, it should be fairly simple. You just need to make x cubed the subject of the formula. You can cross multiply the x cubed here and then bring all this to this side. So this will leave you with x cubed equals to 2 divided by whatever is there. Then to solve for x, just cube root the entire thing, you get 2. So this is the x coordinate of the particle at the instant where dx dt is 0.12. But the question wants us to find the y coordinate. So just simply subtract the 2 inside the original equation of the curve you get the corresponding y value. So that's the answer over there for question 1. So question 1 is a very standard type of question, but fairly straightforward. It's still fairly straightforward compared to the other questions. Okay, question 3. So you have a plot of land over here, right? And the shape consists of 2 equilateral triangles. So equilateral, you need to make sure you label it. And then the rectangle has the sides of X and then L. So as you can see over here. Now show that the area of the plot is given as such. And we know that the area of the plot of land is the area of the 2 triangles plus the 1 area of the rectangle. So how can we find the area of the triangles in the first place, right? And then you realize that your answer, right, only contains X. So there's 2 things you need to do. You need to find out the area of the triangle and the rectangle, right? That's the main thing you need to do. But also, you need to do one more thing before that. You need to express L in terms of X. You have to do this step first because your final answer doesn't contain L inside. So naturally, you need to replace this L with X, and you need to find a way to link these two. So what clues do we have to link these two? The question tells us that the perimeter of the fencing is 130 meters. So that is our only clue so far, and that's what we're going to use. So if the perimeter is 130 meters, that means your X plus X plus X plus X, this is the triangle 1, triangle 2, and this is the length of the rectangle, the exposed length. So essentially 4x plus 2l is 130, which you can then factorize to be 2x plus l is 65. And therefore, you can make L the subject of the formula by just bringing the 2x to the other side. So this becomes 65 minus 2x. And that is where you get to express L in terms of x. And now solving the question becomes really easy. Because to find area of triangle, you know that it's just half AB sine C. Right? This is from your E-math. Half AB sine C. Where your C refers to your included angle. So it always has to be this case. C always has to be the included angle. So, and sine 60 is also your special angle, is square root 3 over 2. So this is something that you should know by heart also, ideally. So this is your area of triangle, and then area of rectangle is fairly simple, it's just length times breadth, where your length is your L, but then you express L in terms of X. So this is your value for your rectangle area. So the entire area is just 2 times the area of the triangle plus the area of the singular rectangle, as you can see over here. So therefore, you just expand out everything, and then you try to work towards this, right? You realize that this one is one singular fraction with a common denominator of 2, right? And with this common denominator of 2, that means you need to make this into a denominator of 2 as well, and this as a denominator of 2 as well. Then you can just combine every one of them, and that's how you will get your answer as shown, right? In fact, you can just write it as this. Just copy exactly what the question wants, as shown. So this part is not so much about differentiation, it's more of just basic E-math stuff. Then now they say given that x can vary, find the value of x for which the area of the plot is stationary. Okay, so if we have the area, right, and area is stationary, so what can we say about stationary values or stationary points in general? Stationary values, stationary points, they are not increasing, neither are they decreasing. Therefore, dA dx should be 0. So now your job is to how to differentiate A with respect to x. So this is how you do it. The first one square root 3x squared, when you differentiate it, you bring the 2 down and then you minus 1 to the power. So this is it. Then when you differentiate 130x, x becomes 1. So it's just 130. Then 4x squared, it becomes 8x. You minus 1 to the power and then you bring the 2 down. So this is your differentiated version of dA dx. And now it's very standard already. They say dA dx is stationary, right? dA dx is stationary because the plot of land is stationary. dA dx is 0 because the plot of land area is stationary. So you let dA dx is 0 and then you solve for x. So that means when x equals to 28.6602 ... meters, the area of the plot of land doesn't change anymore. It doesn't change. So now we want to answer III now. They say explain why when x equals to 28.7 meters, this gives the gardener the largest area of land possible. So we know that when it comes to stationary values or stationary points, there can be many different types of nature of the point, right? It can be a maximum point, it can be a minimum point, or even it can be a point of inflection. So in this context, the question wants us to explain why is the value x equals to 28.7 the maximum value possible, because x has to be the maximum value possible in order to get the largest area possible. So how do we do that? We differentiate your dA dx one more time to get d square a dx squared. And why do we do that? Because we want to show that dA dx is a maximum value. That's why we need to use our second derivative test to find the answer. Alternatively, you can use your first derivative test, which is to just draw the table and then you show that it's a maximum point. It's up to you. But given how dA dx is this, and it's already so easy to differentiate, right? When you differentiate this, you just remove the x. That means you remove the x, and then you remove the 65 because it becomes 0, and then you remove the x over here. It just becomes square root 3 over 4. So I think this method of using the square dx square will be easier because you don't have to draw the table. It's less work. And since d square dx square is negative, we know that since it's negative, it will give us the maximum possible value of a. Maximum possible value of a. And since a is the greatest value possible, that's why it's the largest area possible. So that is the analogy behind this question. So part I is just Amath, II is just dA dx equals to 0, solve for the value of x, and then III is just showing that the square a dx square is negative. Therefore, dA dx is a maximum value. Okay? Now, question 5. Now you have a curve y equals to 2 minus bracket 3 minus 4 x to the power of 4. And the point PQ is the stationary point on the curve. So determine the value of P and Q. So we all know for any curve, really any curve, if the dy dx equals to 0, means it's a stationary point. So in this case, first thing we need to do is to find out what is the dy dx equation, right? And if you want to differentiate this, who becomes 0? So realistically, you only need to differentiate this. And how do you differentiate that? P, I, T. Power inside trigo. There's no trigo over here, so it's just power inside. So how you differentiate the power? You bring the power down. -4. Then you minus 1 to the power, so it becomes 3. And then when you differentiate the inside, you are differentiating this. So when you differentiate 3 minus x, 3 becomes 0, x becomes 1. So therefore, you end up with -1. So your dy dx is therefore just 4 bracket 3 minus x cubed. And since we are trying to find the coordinates of P and Q, or try to find the values of P and Q, which are the coordinates of the stationary point. We let dy dx equals to 0 to first solve for the value of x. So this whole thing equals to 0, right? And since 4 is not 0, so that means this has to be 0. And therefore 3 minus x cubed equals to 0. And we all know that if you cube a 0 value, you'll still get 0. So it's just 3 minus x is 0. Therefore x is 3. And now you know the x coordinate, right? You know p is 3. So you just find the corresponding value of y by just subbing in x equals to 3 to the original curve, because it is after all a point that lies on the curve, right? So you just sub it in, you get y equals to this value, and then yeah, this is your answer over here. Okay, good. Now they say determine whether y is increasing or decreasing for values of x less than p, or for value or b for values of x greater than p. So this II, right, is very interesting because you can use second derivative test or you can use first derivative test, right? But which one would be the smarter way for you to use it? Then you look at the question, and then they say determine whether it is the graph is increasing when x is lesser than 3, or determine the graph when x is greater than less than or greater than. So you know that x is stationary point. So how can we tell at one glance, right, the values of values lesser than x and then values greater than x? That's why I decided to go ahead with the first derivative test, because when we draw out the table for the first derivative test, we will automatically include a value that is lesser than x, then like p, like this p. And we will also automatically include another value that is greater than p. So this kills two birds with one stone, because first you get to tell what is the nature of the stationary point, and at the same time you get to tell whether the value of x that is lesser than 3, whether it's increasing or decreasing by looking at the dy dx value. Same for the values of x greater than p. And also another clue from this question is that in III, they say, what do the results of II imply about the stationary point? Right? So you can use d square dx square, it's fine. But looking at this, III, if you draw the table out, one glance you will be able to tell whether it's a maximum or minimum point. Right? So therefore, I will use first derivative test for this question. So therefore, what can we imply? How do we fill up this table? In fact, this table is your very standard copy and paste table. So I highly recommend you go and memorize how to draw this table. But essentially, your middle value will be your dy dx is 0. Then this value will be just minus 0.1. Just 0.1 will do. And then after that, you just add a plus 0.1. So once you have this, you sub 2.9 into your dy dx, you have a positive value. You sub 3.1 into your dy dx, you have a negative value. And positive values means tangent is increasing, right? Tangent is representative of the gradient. This is flat line. This is decreasing. Therefore, your curve looks like that because your tangents look like this. That means for values of x lesser than 3, y is increasing because tangent is positive. Tangent is increasing. Conversely, for values of x that is bigger than 3. And just from the table itself, you can tell that it's a maximum point, because as you can tell, it's a maximum point. It's the highest, right? Okay, so that being said, in IV, they say what is the value of d square y dx square at the stationary point? So now then we do our second derivative test. So we differentiate the dy dx, we get d square y dx square. So your dy dx is 4 bracket 3 minus x cubed. 4 bracket 3 minus x cubed. How you differentiate this? It's just uv, right? No, it's not uv, it's kv. So you differentiate the 3 minus x cubed. You differentiate the power inside. Power, you bring it down, you minus 1 to the power, you get 2. And then you differentiate the inside, which is just, which is just negative 1. So you just lump them all together, you get this. Therefore, to find the value of the stationary point, or to find the value of d square y dx square, you just sub x equals to 3, because x equals to 3 is the x coordinate of the stationary point inside. And then you realize that d square y dx square equals to 0. This means that using d square y dx square, we will not be able to tell the nature of the stationary point because it's 0. Therefore, the best case would be to just use the first derivative test in this question. That's your best bet, really. Okay, so that's how you do it. Now, moving on. Question 8. Question 8 is a 3-mark question, but it's a super standard question. Super standard question. So you have a function, right? And then they want you to find the values of x for which f is an increasing function. So we know that fx is a cubic equation. How do we know it's a cubic equation? Because when you expand it, you get x squared minus x cubed. Since the highest degree or the degree of the equation is 3, we know it's the cubic equation. And a cubic equation, it sort of looks like that, right? You have this. There's your ups and there's your downs. So we want to find the values of x for which is up, it's going up. So how do we do that? If it's going up, that means your gradient is positive. And since your gradient is positive, your f prime x should be positive as well. So first things first, we need to differentiate this. And how do we differentiate this? This is just uv. So it's u v prime plus v u prime. Right? And you just differentiate each individually. It should be rather straightforward. Then once you combine all of them, you will get this. 2x minus 3x squared is positive. So now this comes to your chapter 1, where you learn how to express quadratic inequalities on the number line, right? And to that effect. So if this one is bigger than 0, how do you solve this? You need to first find out what are the x-intercepts. So essentially x2 minus 3x is 0, right? That means x equals to 0 or x equals to 2 over 3. So you know that the x-intercepts are 0, x equals to 0, and x equals to 2 over 3. But you only want the ranges of x for which f is an increasing function. And in this case, you want to find the values of x for which f prime x is positive. So this is, imagine this is your graph, right? This is your f prime x. You want positive values of f prime x because over here all the values of f prime x are positive. So you only want this. Therefore, your answer is, as long as x is a value between 0 and 2 over 3, f prime x will be positive, and thus f x will be increasing. So that's the analogy of it. Okay, great. So this is a very standard question where they ask you to find values of x for which the function is increasing or decreasing. Okay, next question 14. Okay, you have a curve, and this curve is a quadratic curve because it's negative x squared plus 4x minus 6. The point P lies on the curve and has a x coordinate of 1. So this is your curve, and then P lies on it. This is the x, y, this x coordinate. And then they say the tangent to the curve at P meets the x-axis at A and the y-axis at B. So it kind of looks like that, right? This is your, let's say this is your curve. Okay, this one, let's say this one is your curve. Okay, A and B. Okay, so assuming, let's say this is your curve, then let's say it cuts here. This is a tangent. This is 1y. Then it cuts the x-axis at A and then the y-axis at B. So eventually the question in part A, they want us to find the value of this area over here. Right? Not drawn to scale, definitely. It's probably doesn't look like that. But as long as you can visualize what's happening, then that's all that matters. So you have a quadratic curve where it's negative x squared plus 4x plus 6. And since A is negative, you know it's a set case. And then P lies on the curve and has x coordinate of 1, which is this. This is P. There's a tangent at P, which meets the x-axis at A. So this is A. And then the y-intercept, y-axis at B. So it kind of looks like that. Then they want us to find the area of triangle AOB, which is this green area over here. So O is the origin. So how can we do that? The first thing we need to do is to find out what is the y-coordinate of this. And it's very simple. We just sub x equals to 1 inside the curve equation because after all, it's still a point that lies on the curve. So you just sub 1 inside, you get y equals to -3. So you know P equals to 1, -3. Then that's where the next step is to find out what is the equation of the tangent. And we know that to find equation of the tangent, we need to have two things, gradient and one pair of coordinates on the tangent. Because you can use the formula y minus y1 equals to m bracket x minus x1. Right? So all you have to do is to just sub in values of m and sub in one pair of coordinates just like that. So to find the gradient m, we use dy dx, the gradient function. So you differentiate y equals to negative x squared plus 4x plus 6. How do you differentiate this? In the end, you will get from negative x squared, you get negative 2x. 4x becomes 4. So this is your gradient function, and then you just sub in the x coordinate of P because, well, you're trying to find the gradient of the tangent at P. And then you get dy dx is 2, which is the gradient of the tangent at P. So to find the equation of the tangent, you just use y minus y1 equals to mx minus x1, m being 2, which you have just found, and y1 and x1 being the coordinates of P, because again, the tangent meets the curve at P. That means the tangent cuts through P as well. So you just sub in the values here. And then you just express the entire equation in terms of y equals to 2x minus 5. Okay, now that being said, how do we find the area of the triangle AOB? Right? So it looks like that. You have a line y equals to 2x minus 5, right? Here is 0, here is A, here is B. To find the area of a triangle, in this case, since this is a right angled triangle, you can use half times base times height. The base being the length of the OA and then the height being the length of OB. So to find the length of OA, we just need to sub in y equals to 0 because after all, it is an x-intercept. And then you realize that x equals to 5 over 2. So a equals to 5 over 2 units. Right? And then to find the height, we just sub in x equals to 0 to find the height, to find the coordinates of b, which is 5. So as you can see over here, this is 5 over 2 units. This is 5 units. And therefore, the entire answer is just half times base times height. So this is your answer. Is yeah, just realizing that you need to find the gradient of the tangent and to find the equation of the line, equation of the tangent. And once you find the equation of the tangent, you can find the coordinates of A and B because A is a x-intercept, B is a y-intercept. So you just sub in the respective values of x and y inside to find the coordinates of A and B. And once you find that, you can find the length and the breadth, or the breadth and the height, the base length and the height of the triangle. And therefore, this is your answer. Okay, so now Q. Q lies on the curve as well. The normal to the curve at Q is parallel to the tangent. Okay, so now this one is a mixture. This question tests you on your coordinate geometry knowledge as well. So a normal, as we all know, is perpendicular to a tangent. This is a tangent. Oops. This is a tangent. This is your normal. Perpendicular to your tangent. So since this normal is parallel to the tangent at P, so this is the tangent at P. What can we say about the normal and the tangent? They have the same gradient, right? Because they're parallel to each other. So the first thing we need to do is to figure out that the gradient of the normal at Q equals to 2. And therefore, from there, we deduce the gradient of the tangent at Q, because since they are perpendicular to each other, and for the normal here, the gradient is 2. Therefore, the gradient of the tangent in this case is just -1 divided by 2, which gives us -half. So why do we want to find the gradient of the tangent at Q? It's because eventually we want to find the coordinates of Q. And now we are working backwards, you see. Now we know dy dx equals to half. So we let dy dx equals to half. That means this is the dy dx equation equals to half. So that we can find out what is the x coordinate that gives us dy dx equals to half. Right? We want to find the x coordinate of which the gradient is -half, which is 9/4. So we know that since x equals 9/4, this is the x coordinate of Q. And to find the corresponding y coordinate of Q, we just sub x equals to 9/4 back into the original equation of the curve. Because after all, it is a point that lies on the curve. So we just sub that in, and then we find the corresponding value of y. So therefore, Q is 9/4, -33/16. Okay, so that is it for this question. This question is a mixture of your coordinate geometry as well as differentiation. But by now, in Set 4 topics, you should expect all these. It's like a mixture of all your concepts from Set 3. Okay, question 15. It's a very simple question. They just ask you to strictly find what's dy dx and then obtain the coordinates of the stationary point. So 2 steps. Differentiate it. Differentiate y to become dy dx. That's step 1. Step 2. Let dy dx equals to 0 and then solve. Find the value of x and then find the corresponding values of y. So that's it. Standard, super standard question. So first thing that I did is there are 2 ways that you can differentiate this. You can differentiate it using u over v or uv. right? You can use product rule or quotient rule, but it's really up to you. For me, I prefer product rule because I don't want to deal with very big fractions when I differentiate. So first thing I did was that I expressed this in terms of UV. So this is 2x squared times 1 over x minus 1. And 1 over x minus 1 is just x minus 1 to the power negative 1. So therefore, when you dy dx, it's just uv, right? So it becomes uv prime plus v u prime. And this should be fairly simple to differentiate, right? You just bring the power pit, bring the power down first, differentiate the power, and then differentiate the inside. So it becomes, when you bring down the power, it becomes -1, then you minus 1 to the power, so it becomes -2. And then when you differentiate the inside, you get -1. You get 1 because x becomes 1, and then -1 becomes 0. Right? Likewise for the other side, the v you remain constant, and then you differentiate 2x squared, which gives you 4x. Right? And then afterwards you combine everything. From here to here, the only shift I made was that I made this one squared. So on top I multiply -1 to balance it, x minus 1 to balance it out. Why did I do that? Because I want to combine the two fractions into one. And then I simplified it. So that's your dy dx. And then they want to find the coordinates of the stationary point. So you just let dy dx equals to 0. And then you solve for the values of x. So this is just solving for your quadratic equation. It's just solving for quadratic equations. 2x squared minus 4x equals to 0. Therefore, you can take out the x. Become bracket 2x minus 4. X bracket 2x minus 4. So you know that either x is 0 or 2x minus 4 is 0. So x is 0 or x is 2. And then you just find the corresponding values of y afterwards. Right? You sub x equals to 0 back into the original equation over here. You get y equals to 0. And then you sub x equals to 2 inside the original equation, you get y equals to 8. So you know that when the points are 0, 0 and 2, 0, 2, 8 on the curve, they are stationary. Alright, now, d square y dx squared. What is d square y dx squared? And hence determine the nature of these stationary points. So, recap, dy dx is to find the gradient of the curve. Okay, it's a tool to find the gradient of any point on the curve. D square y dx square is a tool to determine the nature of those stationary points that you have found in dy dx. D square y dx square is a tool that you use to find the nature of those stationary points that you have found using dy dx equals to 0. And what are possible stationary points? They are maximum point, minimum point, last one, point of inflection. Maximum point is when d square y dx square is negative, right? Because the gradient is decreasing. This is maximum point. If it's minimum point, d square y dx square is positive because your gradient is increasing. And then point of inflection, d square y dx square will get 0. And then we need to conduct a first derivative test to test further and really check whether it is a point of inflection or not. Right? Point of inflections look like that. Okay, so that's that. So now you differentiate d square y dx square. Again, I change this back into uv because I prefer to differentiate it this way. And then it becomes uv prime plus v u prime. So in the end, I get this. And then all I have to do is to just sub the values of x back inside d square y dx square and then observe the value. So since it's negative, it's a maximum point. Since it's positive, it's a minimum point. Simple as that. That's it. That's the use of d square y dx square. Okay, good. Next. Question 16. Okay, this is an interesting question. You have a cyclist, right, who's at a crossroads O. He's traveling due west at a constant speed of 5 meters per second. So imagine this is the crossroads. Okay, this O. He's traveling here at 5 meters per second. Right, this is cyclist 1. And then at the same time, cyclist 2 is traveling towards O at 10 meters per second. And cyclist 2 is 100 meters away from O. That's basically it. So they ask you to express OP and OQ in terms of T. So T refers to the seconds, T seconds, right? And how can you express this? So we know that for OP it's very straightforward because it's moving away from O. So for every 1 second, OP increases by 5 meters, right? Because it's traveling at 5 meters per second. So after T seconds, OP will be 5 times T meters away from O. Very simple. For OQ, it's a little bit more interesting because the guy is traveling towards O, not away from O. So the distance between O and the guy, it decreases. It doesn't increase, it decreases as T increases, as time increases. So the answer for this will be taking the original distance where they are away from each other, and then you minus it away from the speed times time. Because for every 1 second, the guy is 10 meters closer to O, right? So now, after T seconds, the guy will be 10 T meters closer to O. And therefore, the distance OQ will be 100 minus 10T. That's for the first part of I. Then they say, hence, show the distance S meters between the two cyclists at time T is given by this. Okay, so this is where you need to visualize a bit more. So assuming this is time T, right? And then you're here. Now it's at T seconds. And they want us to find the length of this line over here. This length over here, just now you measure already, is 5T. And this length over here, you measure already, is 100 minus 10T. And we know that this is perpendicular to each other because the question already given it to us. They are at crossroads and the two lines are perpendicular to each other. So this tells us that if we want to find this, we just have to return back to our Amath fundamentals of Pythagoras theorem, right? Because it is indeed a square plus b square equals to c square, where c square is the length that we're trying to find. So just take a square plus b square. And mind you, this is a minus b squared. So when you expand it out, it should be a square minus 2ab plus b squared. So you should get this. And then 5t squared is just 25t squared. So once you do that, you combine everything. And then since the question wants us to express in this way, you know you need to factorize out the 1 to 5, which indeed gives you this. And then now it's stay in s squared. So you just need to change it to s by square rooting it. But make sure when you square root it, a good practice to always put the plus minus sign. Then reject the negative afterwards because you still have to acknowledge the fact that it can be negative theoretically, but we know that realistically it won't. But theoretically it still can be negative. So you need to put the negative sign and then you reject it afterwards because distance is positive. So short. Then now they say obtain an expression for ds dt. So they want us to differentiate this. Okay, so this is chain rule, right? Because we know that a to the power of a square root a is a to the power of half, right? Cube root a is a to the power of 1/3. So this is your laws of indices, just a recap. So s equals to everything inside to the power of half. So how do we differentiate this? Again, power inside trigo. But in this case, there's no trigo, so it's just power and inside. So first thing, power, bring the half down. Minus 1, half minus 1 gives us negative half. This is the differentiating the power part. Then you differentiate trigo. So you differentiate whatever that's inside here, which will give you 125 because the 125 is not affected at all. Multiply by t squared becomes 2t. Negative 16t becomes 16. Negative 16 and 80 becomes 0. Right? So this is it. Then all you have to do is to just expand everything, right? And express in terms of a singular fraction. Combine and, express everything as a singular fraction. The 2 you can remove here because from here you can factorize out the 2. So if you have 2 minus 8, then you cancel out the 2. So that's how you derive this. And then now, since you already find ds dt, which is the change of distance with respect to time. Now they want us to find the least distance between the two cyclists. So how can we do that? We want to find the least value of s, right? So first things first, if it's a least distance, we know it's the minimum distance. That's why we need to let ds dt equals to 0 first. When you let ds dt equals to 0, you solve for the value of t, which will give you 8. And then that means you know when t equals to 8, at the 8-second mark, the distance is the least or the smallest between the two cyclists. Because when t equals to 8, ds dt equals to 0, right? And then since you know that already, then you find the corresponding distance, which is the least between the two cyclists. You sub t equals to 8 inside the original s equation. Right now, just the t replaced with the 8. So you find that s equals to 44.7 meters. That means the least distance between the two cyclists happens at t equals to 8 seconds, and the distance is 44.7 meters. And just to check your answer, you need to do your first derivative. Because you still need to double confirm that when you let the s dt equals to 0, you are taking the minimum point, right? Because if you don't check this, who knows, it may be the maximum point or even might be a point of inflection. We don't know. So you have to include this in your answer to check, right? So this is your first derivative test to check. And therefore, the least distance is as such, 44.7 meters. Okay? So, yeah, that is question 16. Pretty, interesting. It's very interesting. Okay, question 17. Again, y equals to 2 minus x squared minus 16 over x squared. You can express this as 2 minus x squared minus 16 bracket x to the power negative 2. Right? Laws of indices. This is just 16 times 1 over x squared, which gives you this. So they want us to find the coordinates of the stationary point. Again, dy dx equals to 0. So how do you differentiate this? Differentiate 2 becomes 0. Differentiate negative x squared, you bring the 2 down, becomes negative 2x. You differentiate negative 16x to the power negative 2, the 16 remains constant. Then for the x to the power negative 2, you bring the negative 2 down, then you minus 1 to the power, you get this. So this is your dy dx equation. And then, it becomes fairly simple, right? You let this equals to 0, you solve for the values of x. But just one thing to note is that when you do this, right, when you are rooting this to the power of 4, if this is an even number, you must always put the plus minus sign. If it's like an odd number like 3, you don't have to put the plus minus sign. It's only when this is even, then you must always put the plus minus sign. You have to account for both positive and negative values. So in this case, you know that there are two stationary points, of which the first stationary point, x coordinate is 2. So to find the corresponding y coordinate, you sub x equals to 2 inside the equation of the curve to find the y coordinate. And then to find the corresponding y coordinate when x equals to -2, you just sub it in as well. So you know that the two stationary points are 2, -6 and -2, -6. Then to find nature of these stationary points, minimum, maximum point of inflection, either one of these, the question wants you to use second derivative test. So it's very straightforward. The first mark goes to you being able to get the d square y dx square equation. The second mark goes to you subbing in x equals to 2 and deducing that since d square y dx square is negative, this stationary point is a maximum point. And then the third mark comes here as well. So it's the same thing. So question 17 is really just basic. Is the what I would say is like the introduction type question to differentiation. And just add on, if the square y dx square is 0, you cannot deduce anything. You cannot tell whether it's a maximum, you cannot tell whether it's a minimum, this kind of things. And you can't deduce that it's a point of inflection as well. So from here, you need to use your first derivative test. You need to use your first derivative test. Okay, so that is it for question 17. Now, question 20. You have this over here, right? And they want you to find dy dx. So one glance, I already identified that this is uv. So when I differentiate this, it becomes u v prime plus v over u prime. When you differentiate v, is ax plus b to power of n, right? So you need to use your chain rule. So it's power and then inside. Power, bring down the 3, minus 1 to 3, you get 2. And then when you differentiate the inside, 2x becomes 2. Likewise for the other side. But now the other side is u prime, right? So when you differentiate this, x becomes 1, -2 becomes 0. So it's just 1. Therefore, this is what you get. And then the question wants us to express our answers in ax plus b times 2x to the power -5 squared. So looking at this, here is square, right? Here is cube. So you need to factorize out the 2x minus 5 squared, because that's what the question wants. Once you factorize out the negative 2x minus 5 squared, then whatever that's left, which is this 6x minus 12, and then one more remaining 2x minus 5, which you did not factorize out, you can just combine these 4 terms together, and you get this. So that is the answer for 20i. 20i. So they say, now in II, determine the values of x for which y is a decreasing function. So immediately when I look at this question, I'll think to myself, okay, y is a decreasing function means the gradient is negative, right? Because y is going down, y is going down. That means the gradient is negative. And since gradient is negative, dy dx is negative. So you see your dy dx here is negative. Then now you have to critically ask yourself, okay, so if this one times this one is negative, that means this one is negative or this one is negative, right? You have a negative number, you can't have two negative numbers. You know, if a negative number multiplied by a negative number, you get positive number. So only one of this is negative. So which one will it be? Which one will be negative? And then you look further, and then you realize that when you square any number, right? Like for example, you square -3, you square 9, you square half, you square anything, right? All these will turn out to be positive. So you know for a fact that since you square anything, that thing will be positive, even if it's a negative value initially. You will not accept this because you know that 2x minus 5, the whole thing squared, is positive. So therefore you will conclude that it is indeed 8x minus 17 that is negative. And then you solve for the value of x, you get x is lesser than 218. So that's the essence of that, is to catch that bracket 2x minus 5 squared is positive for all values, for all real values of x. Okay, now I. So they want us to therefore now find the rate of change of x when x equals to 3. So now we are going on to rate of change questions. And before that, in the stimulus, they tell us that when x equals to 3, y is increasing at a rate of 0.35 units per second. That means when x is 3, dy dt is 0.35. Right? Whenever you see the phrase increasing at a rate of, that means it's with respect to time. I repeat, every time you see the phrase increasing or decreasing at a rate, rate suggests is per unit time. That means that is the element of time. That's why it's always with respect to time, dt. So dy dt is 0.35 when x is 3. So you know that dy dt here is 0.35. And you want to find what is rate of change of x. You want to find what is dx dt. So you know this. So you need to find out what's this. Right? And then you know that your dy dx, initially you have gotten this equation here. So all you got to do is to just sub in the values of x when x equals to 3 inside dy dx to find the value of dy dx when x is 3. Then, which is 7. Then you just find dx dt. You just take 0.35 divided by 7. So you should get this as your answer. Okay? Now, IV. They say it is given further that the variable z is such that z equals to y squared. So show that when x equals to 3, z is increasing at twice the rate of y. Okay, so first they tell us there's this new variable, z, and z is y squared. Okay, that's one. And then they want us to show us, they want us to show that z is increasing at twice the rate of y, which is, you know, the increase in z with respect to the increase in y, or the change in z with respect to the change in y, is twice. So the first thing we do is to replace dz dy with 2y. Right? We need to first do that because this is our differentiated equation. Then now our job here is to show that dz dt equals to 2 times dy dt. Right? The rate of increase of z, because with respect to time, is twice the rate of increase in y. So how can we do that? We need to first find the value of y. So now we have dz dy equals to 2y. And this y is referring to our original curve over here. So we need to submit the value of x equals to 3 inside the original expression. to find the corresponding value of y, right? So when you do that, y equals to 1. So that means when x equals to 3, y equals to 1. And therefore, you successfully show that that dz dt equals to 2 times dy dt. And you show that z is increasing at twice the rate of y. That means for every unit time, dz dt is 2 times dy dt. And that's how you essentially prove that this is the case for this question, which is what you're trying to work towards, because they say z is increasing at twice the rate of y. So in your head, you should already tell yourself, okay, eventually I need to show that dz dt is twice of dy dt. Now, how can I do that? I first need to come up with this chain rule equation over here that links these 3 variables together. And once I figure this out, then I need to figure out, okay, how can I express dz and dy in terms of to make it 2, right? Then that's how I get my answer. Then you will differentiate z in terms of y. So dz dy equals to 2y. Then you need to remove the y. But how do you remove the y? You sub the value of x inside the original equation over here to find the corresponding value of y. And just nice, the corresponding value of y equals to 1. So when you sub that in, you get dz dt equals to 2 times dy dt. Okay, so that is how you answer this question. Okay, now question 21. It is given that fx equals to this cubic equation, as you can see over here, right? This is the cubic equation of fx. Now they say find the value of the constant k for which the graph y equals to the cubic equation plus kx has a stationary point, of which d square y dx square equals to 0. Okay, so at which d square y dx square equals to 0, that one not so important because we know that d square y dx square equals to 0 is okay it's important later we'll use it But first thing, the more important thing is to figure out what is the equation first. So y equals to fx plus k. So fx is x cubed minus 3x squared plus 4x minus 12. So you just sub it inside here, then plus kx, right? That's the first thing So they say it has a stationary point at which d square y dx square equals to 0. So there are 2 things you need to do here. First thing, you need to get your dy dx, right? You need to find your dy dx equals equation, because this is how you will get your stationary point. And then you need to use your d square y dx square. Why? Because you know that d square y dx square equals to 0. So using this information here, we are able to find the x coordinate of the stationary point. And once we figure out the x coordinate of the stationary point, because d square y dx square is 0 which means that it is the x coordinate of the stationary point. Then you sub x equals to 1 back inside dy dx to find the value of k, because you know that dy dx equals to 0, right? Like, so in both cases, dy dx equals to 0 and d square y dx square equals to 0. But now you need to use d square y dx square equals to 0 first to find the value of x, the x coordinate. And then once you find the value of the x coordinate, you can then sub that value of the x coordinate back into your dy dx to find the value of k. So therefore, k is just rearrange all this to the other side, and k will just be -1. So yeah, this is question 21, 5 marks. So ideally, we should be able to complete this within 7.5 minutes, including check-in. Okay, good. So now question 31. Okay, this is a very good question. So they say, and it's a very standard question. Water is poured at a constant rate of 18 pi cm cubed per second into a hemisphere bowl, right? We know a hemisphere is half of a sphere, right? So a volume of a sphere is 4/3 pi r cubed. So a hemisphere is therefore half of 4/3 pi r cubed, which gives us 2/3 pi r cubed. And then they say water is poured in, constant rate 18 pi cm cube per second. When the depth of water directly below the center is x cm, the volume of water in the bowl is given by S, like this equation. So therefore, find the time taken for the depth of water directly below the center to reach 9 cm. Okay, so first things first, we need to find what is the corresponding volume first, right? We need to figure out what is the corresponding volume first. Then we can figure out what's the time taken, because water is poured in at a constant rate of 18 pi cm cube per second. That means for every 1 second, 18 pi cm cube goes in. So we need to first find out what is the total amount of volume of water compound that gives us the height of 9 cm. So once we figure that out, then we divide it by the rate of which the water is poured in to find the total amount of time taken for the depth of water to reach 9 cm or the total volume to reach 729 pi. Right? So that's why we sub x equals to 9 inside, because x represents the height, which is 9 cm. So you get 729 pi. Then you divide it by the rate of which water is going in, which is 18 pi. Therefore, the total time taken is 40.5 seconds. Then in II, they say find the rate of change of depth of water directly below the center at this time. So that means at when height equals to 9 cm now, or rather when time equals to 40.5 seconds. So they want us to find the rate of change of the depth of water, which is they want us to find what is this? dx dt. What's this? So using chain rule, we know that we need to make this, we need this two, right? This one needs to be in the numerator. This one needs to be in the denominator. And then these two needs to be the same so that visually they strike each other out. Right? Then now it begs the question. So our equation is V in terms of T. So V in terms of X. So how can we get dx dv if this is V equals to 12 pi x squared minus 1/3 x cubed? How is it possible? So that is where, not sure whether you have learned this already, but it's good to know. In fact, it's a very good tool to use. So your dv dx will give you this. And if you want to get dx dv, all you have to do is to just take 1 divide by dv dx. So you can think it's like flipping a fraction. You take 1 divide by dv dx, you get dx dv. And the proof is here. Y equals to fx, right? So if you want to express x in terms of y, you bring the f over. And how you bring the f over is like your trigo functions. It becomes f inverse y. So when you when you want to differentiate x, or you want to dx dy, right? You differentiate the x. At the same time here, you will differentiate, or you will prime both sides. So therefore, this is the case. dx dv is actually just 1 over dv dx. So it's 1 over 24 pi x minus x squared. So this is the big shift in this question. And once you are able to derive this, then it becomes very straightforward already, right? Because all you have to do is to just sub in the values. This one is your dx dv. And this one is your dv dt. And the question tells you that water is being poured in at a constant rate of 18 pi cm cube. That means the volume of water is constantly increasing at a rate of 18 pi cm cube per second. So we will just multiply these two. Just key into your calculator. If you key correctly, you'll get 2/15 cm per second. So yeah, this question is it's not simple, but the main catch is this dv dx is actually just dx dv is actually just 1/dv dx. And then yeah, that's it. Okay, question 32i. Okay, now 32i. Okay, let me just check how much more. Okay, can 32i. So 32i is as such. You have a gardener who uses 20 meters of fencing and to enclose 2 flower beds, right? The first flower bed is as such. It's an equilateral triangle of side x. So this is your equilateral triangle. And then you have another circle of radius r. Now they say express r in terms of x. Okay, that's the first question now. So what clues do we have so far? What can we find? We can find the perimeter, right? And they say the gardener uses 20 meters of fencing to enclose the 2 flower beds. That means this 20 meters is used to form the equilateral triangle and the circle. So that means perimeter of the triangle plus the perimeter of the circle will give us 20 meters, right? So that's the only clue that we have to work with so far. So let's use this to express r in terms of x. That means perimeter of an equilateral triangle, since one side is x cm, it means all 3 sides add together will be 3x. And perimeter of a circle is just pi d, or in terms of r is 2 pi r, right? Diameter is 2 radius, equals to 20. So now you want to express r in terms of x, or essentially you want to make r the subject of the formula. So how do you do this? You bring the x over to the other side, and then you divide the whole thing by 2 pi. And this is how you get your answer over here. All right. So that is for I. Then now they say show the total area of the 2 flower beds is given by this over here. So you realize that in your area over here, right, there's no r, right? So you need to use your part I answer. Essentially, you need to use your r equals to this one to replace any r value later on. So any r variable, replace it with 20 minus x over 2 pi. So what do I mean by this? Your first flower bed is your equilateral triangle flower bed. And how do we find area of a triangle? The 2 ways, half times base times height, or half a b sine c. And in this case, it'll be easier to use half ab sine c because you know the included angle is 60 degrees, and you know each side is x meters. So just use half ab sine c, you get square root 3x squared over 4, right? Sine 60 is square root 3 over 2, which is your special angle. So ideally, you should know this by heart already. And then your area of circle is just pi r squared. So pi r squared is just the r squared. You need to, as I said earlier, express r in terms of x. So your r need to change to x, which is using the answer that we have found in I. And then you square this. So you get this in the end, right? And the reason why I never expand this at the top is because if you see the question over here, they want it to remain as 20 minus 3x squared. So therefore, area of the flower beds equals to this one plus this one. Make the denominator the same. So you add a pi here, that means the top you add a pi here, and then you combine them into a singular fraction, and this is your answer. Okay? Now, I. So this is your area equation. And they want us to find the value of x, which gives a stationary value of a. So we know that stationary values, the x, in this case, would be 0. So our first job is to differentiate a. And this is just, x squared, you bring down the 2, becomes 2x, right? And then you get this. And then in this case over here, this one remains constant. So you just need to differentiate this the chain rule. So it becomes power inside. Power, you bring the 2 down, minus 1 to the power, you get 1. Then you differentiate the inside, you differentiate whatever is inside here. 20 minus 3x, 20 becomes 0. And then 93x becomes 93. So you combine everything, you get this. Then for stationary values, dA dx is 0. So you let the whole thing equals to 0. And now your job is to solve for the value of x, which gives you a dA dx equals to 0. So from here, it's really just algebra work, right? Since this is minus, we can bring this to the other side, here and here, right? And then all you have to do, since there's x inside here as well, you expand this inside the 2 brackets. So you get this over here and then get this over here. Then next, you bring all the variables that contains x to the left-hand side and all without to the right-hand side. Then lastly, you factorize out the x because this is the only variable you want left. Then you bring whatever value there to the other side. Therefore, x equals to your this one divided by this one, which gives you this, and you can express your answer in 3sx. Okay, so yeah. And then IV, they say find the nature of this stationary value and explain why the gardener may be disappointed. So if he's disappointed means the area is less than what he wants lah. So why would he be disappointed? Because even though he put in so much hard work, the value of x is will give him the minimum value lah. Essentially, the nature of this stationary value is a minimum point. It's a minimum value. That's why he'll be disappointed. So how can we do that? We need to show that d square a dx square is positive. To show that this stationary value, when this one equals to 0, the stationary value that we get is a minimum value. So you just differentiate this one more time. You get d square a dx square. You get this, right? X becomes 1. This x also becomes 1. And then this one becomes 0, which is positive. And since it's positive, the value of x when the stationary value is 0, it will give the gardener the smallest area. And therefore, it will disappoint him or her. And yeah, that is the answer right there. Okay, so I know I still have a couple more questions to go, 33 all the way until 46, but just like 3 more questions or so. I will record them after my next class, and then I'll upload into the drive so that we do not lag behind in class lah. Okay.
So I hope that this crash course was helpful for you. Let me know what you think in the comment section below. And also if you want me to release my other topics for Amath and eMath syllabus as well. Over the next few weeks, I know that now it's the exam season, so I'll be releasing more and more crash courses on this YouTube channel. So make sure to subscribe and also click the link in the description below if you want access to my handwritten notes that I created for this video itself. And if somehow you spotted any errors in the videos, do let me know in the link in the description below as well. And if I check and there's indeed errors, I will send you the revised version completely for free as well. Share this video with your friends if you found it helpful. And if you want a full crash course on vectors from Sec 4 eMath, go and click on this video over here for that full crash course.